Good afternoon, everyone. I just want to check whether I'm audible to all of you. I'm Dr. Aditi Dubey.
Yes,
Ma'am,
I
you are
can
audible.
hear you, ma'am.
Thank you. Thank you.
তো ये লগ ইন করবে তো তাহলে ওই সোয়েলের ইয়ে দিয়ে লগ ইন করতে হবে। হ্যাঁ এটাই তো লগ ইন করছি।
Good afternoon to all of you.
Good afternoon, sir. Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
সোয়েল হ্যাঁ সোয়েল ডট কি ইউজার আইডি ওকে ওকে soel.cs@NITP सर आपको आधे घंटे के बाद फोन करते हैं सर अभी वो एक प्रोग्राम शुरू हो रहा है
Hello.
जो लिखा है सर सोएल स्पेलिंग की जाने लिखे SUYEL एक मिनट पहले ये वाला सेट कर ले फिर बात हेलो
Hello.
NIT कॉलेज के अंदर पूछो yes hello
Hello. Hello.
actually we are waiting for some more participants बिहार में कैंपस के अंदर सिक्योरिटी गार्ड होंगे ना सिक्योरिटी गार्ड तो कौन हाँ कैंपस के अंदर कॉलेज के अंदर सर साइन
I want to know that, sir. Class कब से start होगी? Anyone tell me?
4 o'clock.
Okay,
अभी
okay.
इनॉग्रेशन है, क्लास शुरू होगी 4 o'clock.
Okay, thank you.
So, good afternoon to all of you.
Good afternoon, sir. Good afternoon.
Afternoon, sir.
Good 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 afternoon. I'm Dr. Aditi Dubey.
So, good afternoon and welcome all to this particular course on natural language processing. In fact, I must thank all the academies who are participating in this one for giving such a good response. And we have around more than 650 participants registered for this. 50 participants registered for this course. That's quite a good number across all the academies. And this is what we have planned so far to the participants who have joined. See, the first part of the course, we have tried the basics of NLP and some neural network. And the next part.
Dr. JP sir.
Yes, sir.
You're not audible.
Okay, JP, your voice is very feeble.
Okay, now is it okay now, sir?
Yeah, now it's better.
Okay.
Loud and clear.
So thank you.
Can they start the captions, please?
Caption. So we are trying.
Sir, captions can we start now?
Captions.
We are trying to start the caption, live caption.
It will be adjusted from.
Yes.
Okay, so as I told that around we have, I'm just repeating that more than 650 participants registered for this course. And when we planned all the organization across the academies, we planned that the first part of this course is more or less the basic NLP. And the next part of this course is basically application oriented. Every day we have 2 hours of theory session and 2 hours of practical session. This is a humble request to all the participants that if they can be ready with some a computer, a laptop basically, and Google Colab, then they can really take the most of the benefits of the demonstration session, what our experts will be delivering within that 2 hours. And now with this, I'm not going to take too much of time. I would like to request Dr. Atul Gupta to say a few words on this. Sir, Atul sir. Probably sir is not there. Namita ma'am, if you can say a few words. Okay, sir has.
Am I audible?
Yes, sir. Yes, sir.
So very good afternoon to all of you and welcome to this course on natural language processing. I heartily welcome all of you. I mean, this is a very good course in terms of like getting more and more recognition nowadays because of the advancement of in machine learning and deep learning techniques. Now, like we are in a bit of like making all machines interacting with humans in their natural languages. I mean, something which was considered as impossible 20, 30 years ago, that machine can talk in natural language and can interact with people in their own language. But now, very much the things are very much possible. Even like people are thinking that can we get rid of programming languages, so I can write my program in English or in Hindi or whatever language I used to speak. So I mean, I believe that now the day is not far that we will be writing our programs in natural language. So something which is some like unimaginable, those are happening, and I'm very happy to see that we have this course where we will have wonderful speakers on various topics of natural language processing. I am one of the joint coordinator of this course from IIITDM Jabalpur, and we have got around 200 participants from registered from our academy. So I once again welcome all of you. As you know that this the course will be live streamed on WebEx, and the course material is likely to be shared on Canvas. So as some people have complained that they didn't receive Canvas invitation, so they can wait for a day, because that Canvas invitation is for you to have access to the course material, which organizers are going to share on Canvas. So don't worry if you don't get an invitation now. Maybe in a daytime you will get all those invitations and you will be able to join Canvas. But do attend all the sessions, because I can assure you that these are all going to be very interesting sessions. Those who are interested to do research in the area of machine learning and natural language processing, for them you will find a lot many topics which are potential topics that you can choose for your master thesis or PhD thesis or whatever. So once, thank you very much for joining this course, and over to you, JP Singh sir.
Thank you, sir. Now I'd like to say ask Professor Namita Mittal to say a few words on this.
Good evening, all of you. I hope I'm audible.
Yes, ma'am. Yes.
Yeah. So we, me and Dr. Mahipal, we are from MNIT Jaipur, and 221 participants have registered from MNIT Jaipur, and total 650, as Dr. JP Singh told us. and very happy to see so many participants having, in spite of having exams and other things. And this NLP's course is going to be very fruitful for everyone, those who are inspired to attend it or join it. I would reiterate the things Dr. Atul Gupta has said. Please make it sincere efforts, make your sincere efforts in your theory lectures, because we can see in WebEx those who are not attentive. This is a good feature with WebEx. So your attendance is being recorded. At least 75% we request you to attend, at least. And everything 100% is going to be very well. And we'll be having quizzes as well. And as per the prerequisite, you have to appear in quizzes, then only the participation certificate will be given to you. In case of need, we are always here. All the coordinators, all the proctors, please let us know if you have any problem. Please bring your laptop with you. Always have some understanding of Python. Everything is going to be in Python. And we are happy to share that speakers are well experienced. They have lots of NLP workshops and conferences done. So always there with you, participants. Thank you very much. Thanks for giving us that opportunity, JP Singh sir. Thank you.
Thank you, ma'am. Now, Dr. Amey, Dr. Amey is there. So I request him to say a few words on this. Whether Dr. Amey is there in this list. I can't see him. No, I can't see his name. And from IIT Roorkee, I think Raksha ma'am should be there. So, yes, ma'am, if you can say a few words.
Thank you, Dr. JP Singh. So, I'm Raksha Sharma from Computer Science Department of IIT Roorkee. I welcome all the participants on behalf of EICT IIT Roorkee. A few lines about this course. This course is very well designed. It is covering all the major topics of natural language processing, starting from basic topics like text classification and then leading to sequence-to-sequence models. And another good thing about the course is that it is having very experienced speakers in the field of natural language processing. Few have been like pioneer in the field of natural language processing, like Professor Sriparna Saha from IIT Patna. And yeah, so I'm expecting more registrations in future from EICT IIT Roorkee Academy. This time we are lacking little. And at last, I thank all the organizers, specifically NIT Patna, to take the lead, and all the instructors in the course and coordinators, teaching assistants. Because of them, this course has been possible. Thank you, Professor JP Singh.
Thank you, ma'am. Atul sir, whether Aparajita ma'am had joined?
I think Professor Oza has not joined, so we can continue.
Okay. So, Bhaskar, if you would like to say something, because you are the person who had really... Yes, our expert has already joined, as I can see. Professor Vivek Kumar Singh, sir, from IIT BHU, from BHU, Banaras Hindu University, has joined, and he will be our first speaker. Welcome you, sir.
Thank you, Jyoti ji. Good afternoon to everyone.
So, I think, sir, sir is already here. Already we are reaching 4 p.m. Is there anything more to be shared to the participant? Otherwise, we can start this session. Ma'am. Okay, so let me just introduce our first speaker. So we are moving on to our session. So Professor Vivek Kumar Singh, he is professor and head in the Department of Computer Science, BHU, Banaras, and he has more than around 200 2 crores of project done for various organizations like DST, DAD, Hewlett Packard, and METI, SERV, DST, and so on. In fact, today also he was busy whole day. So thank you, sir, that you take your time from that to attend, to grace us by your presence and lecture. He has more than, say, 100 publications in different outlets of journals and conference proceedings. And he is a very active. In fact, he has, as I told, he is a very active in NLP and has done a lot of project work in that particular area. So I think all the participants, those who are participating in this course, they will be really getting benefited by his experience in handling the projects and through in NLP domain, and how really this NLP works can be utilized in various facets of the life. So thank you, sir, and over to you now. So you can start the session, sir.
Thank you, Jyoti ji. So thank you, everyone, and I'm sorry you'll have to bear with me. I have a little bad throat. So unfortunately, we all, the whole family got stuck up with COVID 10 days back, but that effect's still continuing. So some issues are there. Anyway, so thank you very much. It's my privilege to be here. And I am part of Banaras Hindu University in the Department of Computer Science. I'm there since last 18, 19 years. And I primarily work in the areas of applications of NLP. So I call it text analytics. So that is my main interest. In addition to text analytics, I also work a bit on the STI data, particularly of the science, technology, innovation data for India. And that is another field that is often known as quantitative science studies. So I am working somewhere in between both of them, on quantitative science studies and on text analytics. And that is how most of my work in text analytics is also focused more on scientific articles. So trying to find out, what is there in scientific articles, what are the important concepts that we could figure out, and how are these concepts related with each other. How much do the concepts co-occur with each other? So all these kind of studies that I am mainly involved in. And before this, I also did some work on social media data, largely on sentiment analysis. So for about 5-6 years, from 2011 or 12 to about 2016-17, I was very actively working in sentiment analysis of social media text, and explored a lot of things, focusing on almost all the 3 approaches, where we use a lexicon-based approach, or we use a machine learning approach, or we use something in between both of them, where we try to combine the best features of both of them together. So this is largely what my area of work is. And as per my discussion with Dr. Jyoti, I would largely be talking about introductory stuff, this being the first talk on introductory stuff on text analytics. And my points of discussion would not be on pure NLP, in the sense that I would not be talking about, how do we do POS tagging, or how do we do stemming, or, how do we do word sense disambiguation. But I would be focusing more on the applied part of NLP. That given the fact that we have a lot of advances in NLP and we have a lot of techniques available, what is it that we can do in order to solve real world problems? Problems which may originate from social media data, problems which may originate from industrial data, problems which may originate from data from scientific domains, or problems which may originate from any data on the web. Now, the problem is, so the overall context where we are situated in is that, I will share my slides in a few moments. So the overall context that we are situated in is a context where we design web pages to be read by human beings. But what we want is that, because these web pages are now trillions in numbers, so all these trillions of websites could not be read by human beings. So it is almost impossible for you to read all the websites, all articles, all pages on a particular topic. So what do? We take help of a search engine to give us the best sites, the high ranked sites, and so on. Even then, if you look at all the sites that are there on a particular topic, it is virtually impossible to go through all of them. So what we want is that there should be some mechanism, or there should be some approach possible where machine is going to read all of it for us and is going to give me a glimpse of what is it all about. Okay. So it's like we are designing web pages to be read by human beings. That is the fundamental premise. But what we want more is that these web pages should also be read by computer systems. So a page which is initially designed to be read by human being is now has to be read by a machine. Now that's a fundamental gap that we have, because we never designed a web page to be read by a machine. We designed it to be read by a human being. But what we want is that, because if we would have designed a web page to be read by a machine, then we would have designed it in that manner. For example, we should design it in a database structure where everything is structured and we know what each entity is. And if it is organized like that, then it could be read by a search engine, or it could be read by a web crawler. But what we have is, we have designed it to be read by a human being. And the same applies to a scientific article. We don't write scientific articles to be read by machines. We write scientific articles to be read by human beings. But the problem is that we are in a situation where we are required that there should be some programs which are able to read them and to make the task of reading for us easier. So that is where the fundamental gap is, and that is where NLP comes to our rescue. Now, most of the instructions that we give to the machine is in a very restricted language. Whether you write a Python program, whether you write a C program, you're writing in a syntax which is very, very restricted. Something that could be understood by the compiler of that particular language. You don't write your program in English. I think somebody is in on unmute. If you could please mute yourself. Thank you. So the point is that I'm sorry, I just forgot. Yeah. So the point is that the scientific articles that we write, we don't write them to be read by machines. We write them to be read by human beings. But now what we want is that there should be something in NLP which makes it possible. Now the point is, what is there in NLP? What is NLP? So as we all know, NLP is natural language processing. And what we want is that we want to converse with machines in natural languages. Now, what are natural languages? All these languages which evolved through the natural process of evolution. Let's say you take Hindi or English or Bangla or any language of that kind. Any language which evolved naturally is a natural language. Okay? So if we want to converse in a natural language, at the moment, computer systems are not able to do that. So what you have to do is, if you have to write a program, you have to use a programming language. Let's say Python, C, or R, or whatever language you have to use. Okay. So this gap between what the computer system can understand and what we want to talk to the computer system, there's a huge gap. And that gap has to be bridged. And as you know, this gap is largely bridged by by transforming our own instructions to a restrictive language. So the program that we write, it has to be written in a syntax. It has to be written using words which correspond to a particular language. Okay.
So are you?
No, I have not started sharing slides. I will share just a moment. So this is where the whole fundamental premise lies, that natural language processing deals with processing natural language, processing sentences, processing instructions in natural language. And the point is that at the current state, computer systems are not capable of doing that. And that is where we are all required to design programs, systems, algorithms, approaches, which can allow this kind of processing of instructions written in natural language. So this is what natural language is. And this forces us to understand the natural language, to understand the structure of natural language, to understand the grammar, to understand the rules, because only once we understand that, then we can program that in the machine. So this is what processing in NLP deals with, processing in text analytics deals with. And this is what I would largely be talking about. So I'm sharing my slides. Just somebody confirm me, you can see the slides?
Yes, sir.
And they're changing as well?
Yes, sir.
Okay, thank you. So I would be talking about a topic which is making sense of textual data. Now, this textual data could be of varied kinds. As I said, it could be a social media post, maybe a review of a mobile phone, or it may be a blog on a particular product or a particular service, or it may be a scientific article, or it may be a book chapter. So you take different kinds of sources, you have textual data available. So the point is, can we do some kind of programming? Can we write some kind of programs which can do automatic reading and can give some sense out of that textual data? So this is the broader goal that we have in text analytics. And I have organized my talk as follows. So we'll have a quick look at the overall contextual settings. Why suddenly, everybody's talking about NLP, AI, machine learning, deep learning, and these things. Then we'll have a quick introduction of machine learning and NLP. And then finally, some tasks where machine learning can be applied for text processing. And then two examples I will be showing you, document classification clustering. And then we'll have a look at one practical example where whatever we learn in text analytics can be applied for a business domain problem, which is known as sentiment analysis. So this is largely that I would be talking about. And all these parts are roughly about 15 minutes or so, except that, this part may be slightly bigger, where we talk about the representation part. So before we start, let's have a look at, very quick look at some jobs in the area in India. I'm not talking about jobs which are in US, but very much in India. So this is a job, research scientist, senior research scientist at Xerox Bangalore. I pulled up this post last year. And what does it need is that you need to have background in the general domain of machine learning with deep expertise either in text and image mining, graph mining, structure analysis, statistical relational learning, and so on. And what you should be a PhD or a master's with relevant experience. Now, you may be surprised to know that the pay packet associated with this job is about 1 crore per annum. So, and this job is based in Bangalore. So you don't have to go anywhere other than out of India to earn this kind of salaries. But what you need to have is the right kind of skill set. And what is the skill set that is required in this particular case? If you need to handle text and image data or graph mining, or you can do structural analysis and so on, and you have background knowledge of computer systems and information systems. Another job ad, machine learning or research scientist, Amazon Bangalore. And again, you should be a PhD in machine learning or statistics or optimization or applied mathematics. And you will be largely be responsible with this kind of stuff. So this is for their computational advertising team, where you would be responsible for handling computational advertising. And again, this job is about 90 lakhs to 1 crore per annum. A similar job in Adobe. Now you again see similar kind of skill set that is required, and you need to have a PhD in computer science or computer engineering with demonstrated research excellence. Okay. So this is very important. So often the interviews of most of these companies are 6-7 rounds, where they really judge you whether you have that proper domain knowledge or not. So you need to have demonstrated research excellence in terms of some good publications in good journals or good conferences. Okay. So again, these are 1 crore per annum jobs. So the point is, this is an area where many people are interested in. And not only people who are freshers who are going to start are interested in, but many people who have been in industry for last 10, 20 years, they are also now reskilling themselves. Because this has become an area where, every company is now working in. Almost everything is now revolving around AI, ML, and DL. So whether you're doing software testing, you need to know AI, ML, DL. Whether you're doing some kind of image analysis, you need to know AI, ML, and DL. So almost all problems in computer science and IT, they are now revolving around application of artificial intelligence, machine learning, and deep learning based methods. Why this has happened? Well, there's a lot of things that have changed since 2005-6 onwards. So let's look at the contextual settings. Now, this is some data that I pulled up. This is January 2021. 7.83 billion is the world population. Now, as you could see here, about 4.66 billion people use internet. That is about 59.5% of the world population. About 4.20 billion people use social media, which is about 53.6% of the world population. Of course, this will not be same across the world, because there would be countries where almost everybody is using, and there would be countries where the internet penetration is relatively low. So there are geographical variations. So if you go to Northern America, about 90 out of 100 people use internet. If you go to Northern Europe, almost everybody is using internet. If you come to Middle Africa, 26 out of 100. If you come to South Asia, it's about 42 out of 100. But in absolute numbers, this 42% of a big population becomes a large number, because the population of South Asia is very large. So 42% of large population is more in absolute numbers as compared to 96% of a small population. The other important thing that has changed is we now have social media platforms. So some of you, if you have been using internet for last 20 years, you may have noticed that there was no social media platform before 2005 or 2006. Almost no platform before 2004-5. Okay. Am I audible?
Yes, sir.
Yes. Somebody said I can't hear. Okay. So before 2005-6, there was no social media platform. Even before 2003-4, there was no Google, no Facebook, no Twitter. Wikipedia came in 2001. So almost nothing was there. Internet has been there since 1970s. World Wide Web came in late 1999 or 2000. So actually, late 80s in conception, and actually became commercial in 93-94. So you all know Sir Tim Berners-Lee, while he was working in CERN, he created the prototype of World Wide Web, which became open to public in 93-94 for public use. So World Wide Web is there since 93-94. But World Wide Web changed completely in 2003-4. Because before 2003-4, World Wide Web was largely one-way traffic. Okay? It was largely one-way traffic, where only few people could create content, and most of the other people were only passive consumers. But what has happened in 2004-5 is that World Wide Web transformed into what is now known as Web 2.0. So what happened? Web platforms changed in a manner that they started to allow creation and exchange of user-generated content. For example, if you talk about YouTube, now who creates content on YouTube? Anybody can post a video on YouTube. And that is how YouTube is very rich nowadays, because billions of people create content on YouTube. Who writes on Twitter? Billions of people write on Twitter. Who writes on different blog platforms? Anybody can write. Who writes on Wikipedia? Millions of people write on Wikipedia. So the point is that the new World Wide Web is a World Wide Web which is more participative, which is more user-centric, which is more user-oriented. So it allows users to create content. And that is why we have a lot of content. So social media allowed creation of content, user-generated content, and there are different kinds of social media platforms. So if we go by this categorization, then we have Wikipedia, which is a collaborative project. Then we have blogs and microblogs. Twitter is a very popular microblogging site. Then we have social news networking sites like Dig, LeakerNet. We have content communities like YouTube. We have social networking sites like Facebook and whatnot. There are many, many different kinds of social media platforms nowadays, and some of them are now part of the top IT companies of the world. So you may be aware of the fact is that Meta, which is the owners of Facebook, is now #1 IT company in the world. followed by Google, which is number 2 IT company in the world in terms of revenue that they earn. Microsoft, which used to be number 1 for a long time, is now number 7 or number 8. Because the model that works in getting revenue now is completely different from what it was earlier. Earlier, what was the model? The model was develop a product and sell it. But now the model is develop a product, offer it for free, attract users, and then earn money by advertising. So if you have a platform which has millions of users, you can earn a lot of money by advertising, because all advertisers would be attracted to your site because your platform, because you have a large user base. Well, global social media users have also grown a lot. So in 2016, 2.31 billion people use social media platforms, which has almost doubled in 2021. So in a period of 5 years, the number of social media users has almost doubled. Some examples, just look at some facts. YouTube becomes richer by hundreds of hours of video every minute. So 1 minute passes and about 100 hours of video is uploaded on YouTube. Imagine what is the amount of data center, the size of data center that YouTube would need to store all these videos, and what kind of optimization algorithms that they may be developing to optimize the size of these videos. You look at Facebook, well, 320 million users only from India, and we know India accounts for the largest number of Facebook users. You look at Twitter, more than 500 million tweets are done daily. This number is slightly old, so it may be much more than 500 million tweets at the moment. You look at Wikipedia. Wikipedia is available in 293 languages, and all Wikipedias taken together, they constitute about 40 million articles. If you look at English Wikipedia alone, it has about 5.5 million articles. So this is the exact number of articles as in 2021, January 2021. So this is 5.5 million articles in Wikipedia as compared to 80,000 articles in Encyclopedia Britannica. Now, if you compare, Encyclopedia Britannica took 200 years to develop, whereas Wikipedia is only 20 years old. So this is at least 10 times older than Wikipedia. But look at the content, 5.5 million articles, less than even a million, less than even half a million. Okay. So, and who developed Encyclopedia Britannica? About 4,000 experts wrote the articles in Wikipedia, in Encyclopedia Britannica, whereas Wikipedia, any amateur can write. And that is how we have about 32 million people writing content in Wikipedia. Now, people often complain that Wikipedia content is not accurate, which is no longer true, because many reliability studies have suggested that Wikipedia has a reliability rating of 8 out of 10 as compared to 8.8 out of 10 for Encyclopedia Britannica. Comparing that, it has been developed by experts, and this is only by amateurs. This is not a bad figure to look into. Well, if you look at the top visited sites, most of them are examples of Web 2.0. So what has happened? From 2005-06 onwards, the World Wide Web has changed. Now we have data-driven applications. User is at the center, and it is the user which adds value to a portal or to a website. And users are not seen only as consumers, but they are seen as co-creators. For example, if you remove the videos that has been posted in YouTube by users, YouTube will become useless. So, users are co-creators. And what is the model? The model is that we cooperate and we do not try to control. So it's no longer the Microsoft model where you design and sell. It is more of the Google model where you design and offer for a free, and then you earn revenue out of advertising. So everything is perpetual beta. Nothing is ever final because you keep on getting new versions. So what do we have? We have a data explosion. Why we have a data explosion? Because almost everybody can create content on the web. Okay. And what is this content? this content is a large volume of unstructured data. See, this is very important. This is unstructured data. These are not databases that could be read by machines. These are all web pages where the web pages are unstructured. They are designed to be read by human beings, not to be read by machines. But what is required is that because we cannot consume all this content manually, so we want some bots, we want some programs, we want some automated algorithms to read all of that. So this data may be image or video. This data may be numerical data. This data may be product reviews, which are textual data. This may be blog posts, which is again textual data. So we have a lot of data coming in, and you may have heard about big data, which talks about 3 Vs or 5 Vs or 7 Vs. This data is not only large in volume, but is also coming at a high velocity. And the variety is high, the veracity is high, and so on. So the point is that it is the right situation. It is the right situation where we need these kind of automated algorithms which can make sense out of all this data. Okay. There could be debates on whether the algorithms that we are designing, whether they are acting against privacy of us, all of us. Well, that is debatable, because many times the customization or the user customization goes to such an extent that a lot of your privacy is gone. Okay. So all your browsing history is tracked, all your transactions are tracked, and then you're suggested with a lot of advertisements and so on. So there's a debate on this, but let's for the moment focus on the technical aspect. So what we have is, we have a lot of data, and this data has to be processed using some computational approach. And that is where machine learning comes to our rescue. Now I will have a quick definition of machine learning and NLP, and then we'll talk about machine learning for text processing. Now, what is machine learning? Well, you can read definitions in the book, but what I want to emphasize is that I would like to say algorithms that can learn from data should be treated as an example of machine learning. And what is the job of a machine learning scientist? The job of a machine learning scientist is to build models and to use that for decisions or predictions, rather than following explicitly programmed instructions. And machine learning can be supervised, it can be unsupervised, or it can be semi-supervised. Well, this is a definition. I'm not going into this. So what is happening is that if you're doing traditional programming, you're supplying data, you're supplying a program, and you're getting output, your result as an output. But what is happening if you're doing machine learning? If you're doing machine learning, you're giving the input data, you're giving the output data, and what you're getting is a model. And this model is a model which can solve this mapping, this association mapping from this input data to output data. So what are we doing? We have input data, we have output data, and we are trying to learn what is the association between this input and output. And once we learn that model, we say that we have developed that program which can successfully transform my input data into output data. So this is what I would say machine learning is. And so is it some kind of magic that you give input data and you give output data and you get your programs as results? No, it's more like gardening. So what do? You give, what are your seeds? Your algorithms are your seeds. For example, when you do machine learning, you start with some basic models. Let's say you see, okay, in this situation, I would apply decision tree, or in this situation, a regression model will apply, or in this situation, a machine learning classifier will apply, or in this situation, a clustering method will apply. So you have some broad class of algorithmic approaches, and these are my seeds. And what are my nutrients? The data that I have from my problem, it is my nutrient, and I am the gardener. So you are the gardener. And what is your result? Your result is plants, which is programs. So what is the best part with machine learning is that in machine learning, when you develop a program to solve a problem, you're not solving only that particular problem, but you're also solving all other problems of the similar kind. The same model that you develop with some some alteration, some fine tuning can be applied to other problems of the same kind, of the same category. So this is a simple example that you can see. It is taken from Andrew Ng's course in machine learning in Coursera. So if you have size of a house in a city and price of a house in $1,000, what I'm doing is I'm simply doing a scatter plot. That this is my size and this is my price. And I put the dot based on the data that I observe. Now what I'm trying to do, if I simply look at the data, I will see that there is some linear relationship between the input variable and output variable. So what I'm trying to do is, if this is my price, if y-axis is the output value, I'm trying to learn a function f, which can transform each input value x into an output value y. Okay. And what do I have? I have y1, x1. Okay. I have y2, x2. I have y2, x2. And so on. So I have y3, x3, I have yn, xn. And what do I learn? From all these pairs, I'm going to learn a function f. So if I learn a function f, what is the thing that we can do? If I get any new value of x, what can I do? I can apply the function f on this new unseen value, and I can get what is my output. Because I know what is the rule that transforms every input to output. So in this situation, we can easily guess that this would be a linear fit. So it could be modeled as an equation of a straight line with some slope. So what I do, I have a training set. I have a learning algorithm. This learning algorithm learns from this training set. And this is the model that we develop. So I developed a transformation function. And once I have learned this function, I can apply to any unseen variable and I can find out the actual output. So why machine learning is popular? Well, one reason, we have a large amount of data, but this is a need factor, because we have a large amount of data for which I don't have any other method to solve. We have new kind of problems where there is no known algorithm which can be applied. So there are two need factors. So we have large amount of data, we have new kind of problem. But at the same time, we also have two enabling factors. Machine learning cannot be possible without these two things. We have cheap computing power and we have higher storage, cheap memories. Because most of these machine learning algorithms, they need a lot of computing power and a lot of storage. So had it not been there, machine learning would not have been possible. Now, a wonderful example for machine learning, I would request everyone to please mute yourself. Now, a wonderful example for machine learning in action would be machine translation. As you know, most of the machine translation that people now use, it is no longer rule-based translation, but it is largely statistical machine translation. And what is this statistical machine translation? This is nothing other than a parallel corpora with a suitable model. So what is this parallel corpus? You have billions of sentences in language 1 and you have equivalent sentences in language 2. So let's say if this is Hindi and this language is, let's say, English, what do you have? You have billions of sentences in Hindi and you have their equivalent sentences in English. And then you do what? You learn a model. You learn a model for symbol manipulation, for symbol substitution, for symbol transposition. That whenever this word comes or this pattern of words comes into the sentence, this should be replaced by another sequence of patterns from language 2. So this is what all that we are doing in a statistical machine translation. So either this could be some kind of HMM based model or whatever model that we have. Okay. This is what we do in statistical machine translation. And as you know, most of the machine translation that happens nowadays, which is quite accurate also, including the one which is used by Google, it is a statistical machine translation. So what do you need? You need, so the beauty is where? The beauty is in the parallel corpus. The same model that you develop for translating from language Hindi to English, you can develop a similar model for Spanish to German or Spanish to Russian. What is the overall thing? The overall thing is that we have the same kind of model. And once I have developed a model for a language pair, then I can apply any input text and I can get the output text. So this is where a machine learning model is being used for symbol manipulation. Well, we have talked so much about machine learning, but if I'm a machine learning scientist, what do I do really? What most of the people who are machine learning scientists, they're really doing. So what society thinks I do is that there are a lot of machines I'm training. What my friends think I do is that there's some complicated robotics and so on, and I'm programming it. What my parents think I do is there are large computer systems and I'm programming them, doing some very complicated stuff. What other programmers think I do if I'm a machine learning designer is that I'm doing some complicated piece of mathematics. Even what I think I do is something very complicated stuff, something very sexy stuff that, it is very attractive and so on. But what I'm really doing, most of the people who are machine learning designers, they're really doing what? Well, importing programs, importing functions from Python libraries. Well, that is true to a large extent, but at the same time, it is equally important to understand. It is equally important to understand what model applies where. So as a person, we may not have to code everything. We may not have to code the support vector machine model. We may not have to code the name Bayes classifier. We may not have to code, Rockio's classifier or conditional random field classifier or even a logistic regression classifier. We may not have to code for that because functions are available. But what we need to do, we need to know how to import, which libraries they're available. And at the same time, we need to know my data. What is my data? What is more suitable model for my data? What is my problem? What is my data? What is my problem? What model would be applicable here? That is where you need to know machine learning. You need to study machine learning in the sense that what are the different models available? What are the different kinds of models available? And in which particular situation, which model will apply? What are the pros and cons of different models? Well, if you want to read more about machine learning, these are wonderful books. This is a classic. These two are very good books. And if you're more a MATLAB fan, you can read this book by David Barber on Bayesian reasoning machine learning. Most of the code is available in MATLAB. And here you have most of the stuff either in Python or R. So it is a time of reuse where we are reusing a lot of libraries, a lot of code that is already available. And that is where, we have GitHub, we have rich libraries in R, we have rich libraries in Python. And it is, in fact, it is the best time to solve a problem. You want to learn anything, you have plenty of resources. You want to learn a model, you have plenty of resources. You want to study something, you have plenty of resources in terms of online courses and so on. Okay. Let me quickly go through another problem where machine learning comes to our rescue and where text processing is also involved, is information retrieval. Now, what happens in information retrieval? There are trillions of web pages. You're looking for pages on a particular topic. Well, of course, you can't visit all of them. So what you do, you talk to a search engine and you give to the search engine your topic, and then the search engine gives you certain results. And how do you do it? Well, you have an information need on a particular topic, you issue certain query terms. there would be a lot of documents, and some document terms would be matched, and you have a set of results, and they are provided to you in a ranked order. But the question is, when you do Google search, how many results do you get? Many times you get millions of results. Do you really go through all of them? Well, I think all of you will answer no. We don't go through all of the results. What do? We look at results in the initial pages. So that is why it is very important that the most relevant results are shown in the beginning. So the results should be ranked in a proper manner, that the most relevant results are shown right in the beginning of the result set. How do we rank? Well, a bit of text processing and a bit of machine learning. So learning to rank is the most popular function that is now being used for ranking web pages. So what do you have in IR? You have a document collection. If you're doing web IR, what is your document collection? The entire World Wide Web is your document collection. What is information need? Suppose you're looking for articles on, let's say, blockchain. So your information need is on blockchain. And what is relevance? Relevance is a notion where somebody should tell that whether, if I'm looking on blockchain, all the documents that I obtained, whether this is actually about blockchain or not, whether it is relevant or not. Okay. And what is the goal of a search engine? The goal of a search engine should be that it retrieves all documents with the information that is relevant to the user's information need. And you may have heard about precision and recall as measures, that we want to have highest precision and highest recall. What is precision? That the results that are obtained, the largest fraction of that result should be relevant. And what is recall? Out of all the relevant results, we are able to retrieve most of the results. So what happens is that what is visible to you in the foreground is this part. You give a query, this query is parsed, expanded. This becomes a system query. It is subjected to a retrieval and ranking function. And then we get certain answers in a ranked order. But what happens in the background is this entire stuff. So we have World Wide Web. We have a lot of web crawlers. They collect the whole of the web in local collection in my central repository. So every search engine has a central repository. In fact, most of the popular search engines have distributed central repositories. And then we have an indexing process, which indexes all this by keywords. So what happens? If this contains billions of documents, in fact, it would be much more. What I'm going to do is I'm going to read all these billions of documents, and I'm going to extract all the distinct words. All these distinct words extracted, that constitutes the vocabulary. So I list the vocabulary, and then I create the postings list. I call it postings list. So for each word, what are the documents in which this word occurs? So I have to arrange all those documents by their document IDs. And we have to maintain an efficient data structure, because this would be a large one. So often what we do is we maintain postings list. And this inverted index is very, very huge in memory. So storing it in primary memory often becomes impossible. So we store it in secondary memory. And we need an appropriate data structure to store, because we need to have a quick lookup into the inverted index. Why we need to have quick lookup? Because you are giving a search query and you need to have the answers quickly. And as you may have noticed, most of the search engines give you the answers very quickly. So this inverted index lookup is very quick. So what you get your answers from, it is not from a real traversal of the web, but this traversal is already done in the offline fashion. And this inverted index is already created. So what you get as a retrieved result is something that is already constructed result. And then you are shown in a ranked order by some ranking function. Okay. Now, how do we do this ranking? In order to understand this, we need to understand how do we process text? How do we represent? Okay. So there are two popular representations of textual documents. One is graph-based representation, the other is bag of words model, which is also known as vector space model. So all textual documents that we have, they are stored as vector of numerical values. So we call it as vector of numerical values, term values. And usually these term values are called TF into IDF. So we use term frequency multiplied by inverse document frequency as a weight for each term in each document. So as you can see, each document, each text document that you have, it is converted into a numerical vector, where each numerical vector comprises of numerical values. And each of these values is basically a TF into IDF value. Now I'm just coming to what is TF, what is IDF. But before this, what we need to understand is that suppose there are total n documents in your document collection. And all these n documents taken together, they have m distinct words. That is, the vocab size of this whole collection is m. Now, let it be very clear, n documents total, and all these documents taken together, the total number of distinct words that are there is m. So what I'm going to do is that I'm going to represent all these n documents, document 1, document 2, document 3, document 4, up to document n by a vector where each vector is of size m. And what is m? M is the total number of distinct words in the whole collection. So if you have 200 documents and 200 documents totally comprise of 5,000 words, then each document will be represented as a vector of 5,000 values. All these 200 documents would be represented as a vector of 5,000 values. All these are weights. Okay? All these are weights. Now, how do we compute these weights? There are a lot of choices, but I'm only telling you the most popular choice. So this weight is often calculated as TF into IDF. What is TF? This is called term frequency of a term I in document J. What is this? Essentially, this is log of Fij. What is Fij? How many times does the term I occur in document J? If it occurs more than 0 times, this is the frequency count. And then we do some log normalization, and then we do some Laplacian correction. If it doesn't occur, then the term frequency is 0. So the point is, if a term occurs once in document, it would be 1 plus log of 1. If it occurs 100 times, it would be 1 plus log of 100. If it doesn't occur, its term frequency in that document would be 0. What is IDF? IDF of a term is for the whole collection. Okay. Now here Fij, I just told, Fij is the frequency of occurrence of a term I in document J. So if a term occurs 100 times, then Fij is 100. And then 1 plus log of 100 becomes my term frequency Ij. So term frequency is nothing other than frequency, but it is a log normalized frequency. And what is IDF? This is inverse of document frequency. What is document frequency? Document frequency of a term I is the number of documents in which that term occurs. And what is inverse? Inverse of that. So what is inverse document frequency? The inverse document frequency is computed by log of n by ni. What is ni? Ni is the document frequency. So if you have a term and n is the total number of documents. Suppose you have 200 documents. Okay. So your n is 200. And out of 200, there is a word which occurs only in 10 documents. So what is my IDF? Log of 200 by 10, which is log of 20. But suppose there is a word which occurs in all these 200. There may be a word, for example, the. The is a very popular word which occurs in almost all web pages. So what it would be? This would be 1. And what is log of 1? Is 0. So inverse document frequency of terms which occur in all documents will become 0. And when is the TFIJ 0? TFIJ is 0 whenever term doesn't occur in the document. So what do? We say Wij is equal to TFIJ into IDF I. I'm showing you with an example, so this will make it more clear. Suppose this is a toy example. Suppose you have 4 documents. Please pay your attention here, because then you will not understand the rest of the discussion. Suppose there are 4 documents, and as you could see here, these are toy examples, very small documents. I want to represent all these documents into numerical vectors. So I want to have D1 vector. I want to have a D2 vector. I want to have a D3 vector. I want to have a D4 vector. Now, all these vectors are what? All these vectors would be vectors of numerical quantities. So what I'm doing, I'm transforming my textual documents into numerical vectors. Okay. This is what the vector space model is. Now, what is my first step? My first step is I need to know what is the total number of words that occurred, the total number of distinct words that occur in all these 4 documents. So what is the vocabulary size? Now, if we do it, we find that this is the vocabulary. That all these documents together, all these 4 documents together, they comprise of 14 distinct words. Okay. So then what is my next step? I want to represent each document as a document vector. So first I compute the term frequency vector, then I compute the IDF vector, and then I multiply TF with IDF. Now let's see how do we compute TF vector. TF is what? 1 plus log of Fij. Now let's look at the first term 2. 2 occurs how many times in document 1? 1, 2, 3, 4. It occurred 4 times. So what is 1 plus log of 4? Suppose we take base 2. So log of 4 on base 2 is 2. So 1 plus 2 is 3. So I get a value of 3. Now let's look for the same term 2 in document 2. How many times does it occur? 2 times. So 1 plus log of 2 on base 2 is 1 plus 1. So we get the value of 2. Now let's look at the value DE in document 1. How many times does it occur? 1, 2. So we have 1 plus log of 2, which is 1 plus 1, which is equal to 2. So that is how we are creating term frequency vector 1, term frequency vector 2, term frequency vector 3, and term frequency vector 4. Now let's look here. How is this 2.585? What is this term? This term is DA. Now DA doesn't occur in first document, so this is blank. It doesn't occur in second, so this is blank. It doesn't occur here, so this is blank. So in fact, all blanks are zeros. Now it occurs in the last one. How many times? 3 times. So 1 plus log of 2 on log of 3 on base 2 is 1.585. So 1 plus 1.585 is 2.585. So we get this value. Okay. So these are TF vectors. The next step is I have to compute the single IDF vector. The log base could be anything, but most popularly it is used as 2. It could be 10 or anything. So it depends on what is your base. The values would be smaller or bigger. Now, in order to compute IDF, what do I need to do is there would be a single IDF, because this IDF is the whole vector for the whole document collection. Now let's look at the first term, 2. Okay. How many times does it occur here? Does it matter how many times does it occur here? No. What matters is in how many documents does it occur. It occurs in D1, it occurs in D2, it doesn't occur in D3, it doesn't occur in D4. So what is document frequency? Document frequency is 2. Okay. So what is IDF? Log of n by ni. What is n? 4. There are 4 distinct documents. 4 by 2 is 2. What is log of 2 on base 2? Log of 2 on base 2 is 1. So I get the IDF value as 1. So that is how I compute IDF. Now one question may be, why do we really compute IDF? What is the need for IDF? Why can't we only represent the documents as TF vectors? Well, the point is that I want to give more weight to terms which are more distinctive for a particular document. I want to reduce weight of terms which are very commonly occurring across the documents. So commonly occurring terms like the, is, am, are, not, and so on, which are very frequently occurring in all the documents. They do not have any distinctive association with any specific document. What I want is that those terms which give some distinctive meaning to a particular document should get more weight. And those terms which does not have this distinctive characteristic should get less weight. So what will happen? Because I am computing IDF, any term which occurs in all will get weight 0. For example, here BE. Now BE occurs in all 4 documents. So log of 4 by 4 is log of 1, which is 0. So what will happen? When I multiply TF with IDF, the weight would be a mix of both things. How many more times does it occur in one document multiplied by how common is this word. If this word is very common, its weight will become 0. So which is a good word? A good representative word is a word which occurs many times but in a small number of documents. That means the term frequency is high, but the IDF is also high. And IDF would be high if a term occurs only in less number of documents. So what I do is I multiply TF with IDF and I get, these are my vectors. So what was my starting point? My starting point was these textual documents. And what did I do? I converted all of them into numerical vectors. Now, what is the advantage? What is the benefit that I get out of converting all this into numerical vectors? Well, one biggest advantage that I get is that because I have all these documents represented as vectors, so I can apply the whole vector algebra on all these vectors. So when I say I can apply the whole vector algebra, I can say this. I can find out dot product of D1 with D2. So I want to find out how similar are D1 and D2. What do I get? D1 multiplied by D2. Somebody asked, how do we get D1, D2? Well,
Sir, can you repeat this?
This is very simple. You have D1 vector, you have the term frequency vector here. Then you have the IDF vector here. So you multiply this IDF vector into all the term frequency vectors. So term frequency 1 vector becomes D1 vector. Term frequency 2 vectors becomes D1, D2 vector. This becomes D3 vector. This becomes D4 vector. So we have all this into the vectors D1, D2, and D3, D4. I will share these slides so you can also have a look later on. So what do I have? I want to find out how similar is D1 with and D2. What can I do? Manually, I may have to read the documents to tell whether D1 and D2 are similar. But I can do it with a computer program. What can I do? I can take a dot product between D1 and D2. And I define it as cosine similarity. So cosine similarity between two vectors is nothing other than dot product of their unit vectors. And the same thing I can apply for information retrieval. Suppose I have a given query and I want to find out which document should be ranked highest for this query. I can do this. Q into D4, Q into D3, Q into D2, and Q into D1. And based on whichever gives me the highest cosine similarity value, I will tell that that particular document should be ranked highest. Okay. So this brings us, because we have represented all these documents as vectors, so this brings us to the notion of similarity. And the idea is that we always look for semantic similarity. We say that we are interested in two documents, whether two documents are semantically similar or not. But the point is, it is very difficult to compute. Well, you have to read it. Read the documents to tell whether they are semantically similar or not. Or the document should be represented in some kind of semantic web structure so that you can tell. But if the documents are not represented in that way, then it is very difficult to tell how semantically similar two documents are. But it may be easier to tell how syntactically similar two documents are. What can I do? I can take cosine similarity. Okay. And the idea is that in most of the cases, syntactic similarity is a good approximation of semantic similarity. Syntactic similarity can be taken as a good approximation of semantic similarity. Okay. I would request you all to please mute.
I request the coordinator to auto-mute all the participants so that this disturbance will not be there once again.
Please mute everyone. The coordinator can do that.
Deepti is creating disturbance.
So whosoever has the control, please mute everyone. Okay. So now, so the point that I'm making is that syntactic similarity is a good approximation of semantic similarity. So what we can do, if I want to find out cosine similarity between two vectors, what I can do, VD1 divided by its norm, that becomes unit vector D1. VD2 divided by its norm, that becomes unit vector D2. So what I do is I take dot product of two unit vectors. Okay. Somebody is asking, why do we take base 2 when we take IDF or TF IDF log normalize? It is not necessary that you take base 2, you can take any base. It is only log normalization. If you take base 10, the values would be smaller. If you take base 2, the values would be bigger. But any base is possible. So similarity between D1 and D2, we take VD1 into VD2. So taking the dot product element by element. Okay. And as you know, cos theta, that is why we call it cosine similarity. Cos theta between two vectors would be 1 when theta is 0. So cos 0 is 1. Now, when is theta 0? When the two vectors completely overlap. So that means two documents would be exactly similar if they are completely overlapping. Okay. So the same logic can be applied for information retrieval. I can find out which document should be the most similar to a given query queue. So what can I do? Suppose I have 100 documents and I have a query queue. I want to find out that which document should be ranked at first place. What can I do? I can take query dot product D1, query dot product D2, query dot product D3, query dot product D4, and so on. And whichever vector gives me the highest value, I will tell that this vector has the highest cosine similarity. As you see here, we take dj divided by norm of dj, q divided by norm of q. Why do we this norm? Why are we dividing? We are length normalizing. So now we divide the vector by its norm in order to length normalize the vectors. Because what may happen is that a query may be comprising of just say 10 words. One document may be comprising of 1,000 words. Another document may be comprising of 10,000 words. So what will happen if the bigger ones are multiplied, the values may be higher. So that is why what we are doing is we are length normalizing vectors. Okay. And how do we length normalize? We take the norm, and what is the norm? Square root, under root of squared values, sum of squared values. So for example, if the same toy example that we saw, if my query term is to do, how do we process further? Well, the first step is convert this into a TF IDF vector and then compute cosine similarity of query vector with each document. If you do it, you will find out that QD1 is 0.660, QD2 is 0.408, QD3 is 0.118, and QD4 is 0.058. Okay. So you can clearly tell that the highest cosine similarity value is for D1. That means D1 should be ranked at first place in the order of relevance. So what is this called? This is called query dependent ranking. What I'm doing, I'm computing cosine similarity of query with the document. And if I change the document or if I change the query, the rank will change. So that is why we call it as query dependent ranking. But Google, or for that matter, any search engine, they don't use only query dependent ranking, but they use many other strategies. And some of them are query independent. For example, PageRank. As most of you may be aware of, PageRank is an algorithm which is there for query independent ranking. What do we do in PageRank? In PageRank, the rank of a page is calculated based on the link structure. So how many pages I am pointed by, what is their page rank, and so on. So based on that, I will have my page rank. And page rank is also a rank, but it is query independent rank. Page rank of a page will remain same, whether this is retrieved for query 1 or query 2. But the query dependent ranking will change with respect with all these queries. Okay. So I'm giving you an example, an exercise that you can do later on. I will share the slides. Suppose the same thing I want to repeat here, D1, D2, and D3. There are three documents, D1, D2, D3, and I have a query new times, and I want to find out which document should be the most relevant to new times. So what I need to do is I need to convert all these D1, D2, D3 into numerical vectors. I need to compute, change the query in numerical vector. I compute all of that, and then I take dot product of QD, D1, QD2, QD3, QD4. So we take cosine similarity of D1 with Q, cosine similarity of D2 with Q, cosine similarity of D3 with Q, and we get the values as 0.776, 0.292, 0.11. So the one with the highest value would be ranked at the first place. Okay. So if you want to read more about information retrieval, there's a course that I teach in IR. You can get some material here. But other than that, you have two wonderful books on information retrieval. One of them is free to download, Christopher Manning, Raghavan and Schutz. And then you have another book, Ricardo Biza Yates, Modern Information Retrieval. Use the second edition.
Excuse me, sir. I have a question, if you allow, in the previous slide.
Yes, please.
Sir, yes. So for calculating the vector for each query, there must be some fixed vocabulary which is used to calculate the vectors of query as well as the document, right?
Mm-hmm.
So because in this query you have not shown the documents, so what vocabulary is consisted
These
of?
are the documents. The documents are here. D1 has New York Times, D2 has New York Post, D3 has Los Angeles Times. If you count, there are 6 distinct terms.
Okay.
Yeah. So you have Angeles, Los, New, Post, Times, York. D1 does not contain Angeles, Los. It contains New 1 times, Post 0 times 1, 1, and so on. And so this is my term frequency. This is my inverse document frequency. Okay, then I compute term frequency multiplied by inverse document frequency. So each of my vectors are now these vectors. Then I compute query, I convert the query into query vector. Then I length normalize D1, D2, D3, and D4, which is my query vector. And then I have cosine similarity of D1Q, D2Q, D3Q. And that is how we get these scalar values. Okay.
Okay, sir.
Well,
Sir,
a good question. A good question is what happens if the keyword is not in the vocabulary? Well, nothing happens in that case. That word is ignored. If you issue a query with a word which is not there in the inverted index, that word would be ignored. Or if you issue a query for a word which is not at all there in inverted index, you will not get any result. And this may have happened with you in Google also. If you purposefully misspell a word, so in such a complex manner that it doesn't make any sense, then you will get 0 results. Okay?
Sir, how we are converting query into vector?
Well, query is also converted into vector in the same fashion. See, I have shown you. If your query is to do, then what do? You compute the TF-IDF. Now, what would be the size of your query? Your size of query would be equal to M, where M is the total number of distinct words in the document collection. In this case, this is 14. So each query would be 14 values. Out of this, to do will have some values, rest of them would be 0. Okay?
Okay, sir.
Word tokenization and word vectorization, they are different terms, right?
Well, yes, they are different. Word tokenization, tokenization itself has a lot of issues because it is not very straightforward that we know how do we tokenize. For example, in English language, it may be easier to tokenize because we have blank spaces. But what about Chinese? What about Japanese? In Chinese, you don't have spaces between two words.
Yes.
So Chinese tokenizers are more complex to build.
Yes.
In German, they often use very large compound words. So you can't tokenize without having a compound splitter. So tokenization itself is a challenge. And there are many, many issues associated with tokenization. Now, for example, if you say Hewlett-Packard, now Hewlett-Packard, whether Hewlett and Packard should be two separate tokens or they should be same token.
Yes.
If you say state of the art, whether it should be same token or it should be all words as distinct token. If you say Los Angeles, now whether Los should be separate, Angeles should be separate, or they both should be same. So there are a lot of challenges associated with tokenization itself. And tokenization, as we know, is language specific.
Yeah.
So tokenization is recognizing what is my unit of processing. So if I say this is my one token, then that becomes one part of my vocabulary. And vectorization is where I convert these tokens into numerical values.
Yeah, what we did is vectorization.
Yes.
And then this is the standard procedure. Is there any other ways of vectorization?
For vectorization, this is all that we do. The other way to represent the document would be if you represent it in a graph.
Yes. Yeah, I would like to thank you for explaining so well, because TF-IDF concepts were clear before, but then I didn't know how the TF-IDF was related to the word vectors. So thank you
very much. So it's very easy to follow. TF-IDF is very easy to compute. And as you may see in books, there are different variants of TF-IDF. I am only showing you one variant. So many times people use different variants. Say, for example, some people don't do Laplacian correction. Some people use the raw frequency. So there are different variants.
Okay, so variants will be there. Okay, thank you.
Okay, let's move further. A quick introduction to natural language processing. So this is something that I think I have to be very quick because most of you already know what natural language processing is. Well, usually shortened as NLP, and it's a branch of AI that deals with interaction between computers and humans using natural language. So most of the interaction that we have with computer systems is in a language which is alien to us, and the language that we speak is alien to computer systems. So we have to build a lot of translators in between us and human and computer systems, and that is where what we want is that we should. Yes.
Sir, sorry to interrupt you. Sir, how TF-IDF differs from bag of words?
TF-IDF is not different from bag of words. TF-IDF is the representation of bag of words. So bag of words is a vector space model. Is the first step of bag is the vector space model, and TF-IDF is the numerical values converted from bag of words.
Okay, sir.
Okay. So it is interaction. So NLP basically can bridge the interaction gap between us and computer systems. And what is the ultimate objective of NLP is to read, decipher, understand, and make sense of the human language in a manner that is valuable. And what you can imagine is a typical interaction between humans and machines could involve following NLP tasks. A human talks to the machine captures the audio is converted to text, the text is processed, the processed data is converted into audio, and this audio is again placed by the machine. So if you're talking to a robot, then in a natural language, then whatever you talk has to be first converted into text document, and this text has to be processed by the robot, and then whatever resultant text is there, it has to be again converted into text to speech. So you need speech to text, then you need text to speech, and other than that, you also need text manipulation algorithms. So something like question answering or text responses. So NLP entails applying algorithms to identify and extract natural language. And the most important part is this is unstructured language data. And there are a lot of challenges in NLP that people work on speech recognition, which is the audio to text part, on natural language understanding, which is the text processing part, and then natural language generation, which is the speech to audio part. There are a lot of challenges associated, such as syntax and semantics. Syntax refers to the grammatical part, which is arrangement of words, and syntactic analysis used to assess how the natural language aligns with the grammatical rules. And as you know, there are a lot of processing that we do in NLP in syntactical processing. We do lemmatization, then we have morphological segmentation, then we have word segmentation, we have part of speech tagging, we have parsing, we have sentence breaking, we have organization, we have stemming. So there are a lot of things that we have in syntax. I would request everyone to please mute yourself. Then we have semantics. Semantics refers to the meaning that is conveyed by a text. So semantic analysis is one of the difficult aspects of natural language processing, and it involves computer algorithms to understand the meaning and interpretation of words and how sentences are structured. Well, I don't understand why you don't listen. I sincerely and honestly request everyone to please mute yourself if you don't have a question. In semantics, you do a lot of things. We have named entity recognition, we have word sense disambiguation, we have natural language generation, understanding, question answering. There are a lot of problems that we have here. Okay, let's come to the final part, which is machine learning and text processing. Just give me a minute. Okay. So we have a lot of text processing tasks, and all these are application tasks. One of them is classification. Suppose I give you an assignment submitted by a student, and I ask you to write a program to classify that into its topic. Let's say I want you to tell whether this assignment is about computer architecture, or this is about software engineering, or this is about artificial intelligence. And if you know how to do it, and if I give you 1,000 documents, you can write a program and you can automatically categorize them into which assignments are about computer architecture, which are about software engineering, and which are about AI. So what is classification? Classification is often known as supervised machine learning, where what we have to do is we have to classify a document into a given target class. We may have 2 target classes, we may have 1 target class, we may have more than 2 target classes. Okay. So if we have 2 target classes, that is binary classification. If we have more than 2 target classes, then we have multi-class classification. The other problem that we have is clustering. Now, clustering is often known as unsupervised machine learning. Why we call it unsupervised is because we do not have the target classes here available. So what we are told is that we have a group of documents which are there into multiple of different types, different groups, different kinds. And you have to group them in a manner that all documents which are similar, they are grouped together, and documents which are dissimilar should be in different groups. You may also be told sometimes that there are 3 groups or there are 5 groups. And you have to group them in a manner that all the 5 groups have the right set of documents in that. So this is called clustering. So there are algorithms for classification. There are algorithms for clustering. Then we have a task called sentiment analysis. It's a very highly applied task on which many companies are working. And what is the task? The task is, given a review of a product or a service, this could be a hotel, this could be a mobile phone, this could be an airline, or this could be anything. Can we write a program which can tell me whether this review is positively oriented or negatively oriented? So then we are doing sentiment analysis. Now, sentiment analysis can be done at multiple levels. It can be done at the whole document level, where we tell whether the document is positive or the whole review is positive or negative. It can be done at sentence level, where we tell each sentence whether the sentence is positive or negative, or it can be done at feature level, where we classify the features and the opinion about those features into different sentiments. Okay. Then we have summarization. Given a large document, can you write a program which can automatically generate a short summary? You may be doing single document summarization, or you may have to write a summary for multiple documents. So based on that, we may have SDS or MDS. Then we may have disambiguation, which is more NLP oriented task. Given a sentence, to disambiguate what is the context in which it is used. For example, if I tell you, yesterday I went to bank. Okay. Yesterday I went to bank for fishing. So unless I tell you for what purpose, you will associate bank with a commercial bank, because that is a more popular use. But when I tell you I went to the fishing, then you will say that it was a river bank. Then we have topic modeling. Given a large number of articles, can you identify what are the important topics or trends or themes discussed in these articles? Or given a set of articles, can we extract what are the names discussed here? What are the entities discussed here? Or going for a bigger role, can we machine read? Can we do machine reading? Can we do question answering? Can we do something called, visual question generation? I show you a set of images and you tell me a question about those images. So there are a lot of challenges associated with text processing, and a lot of them could be processed by appropriate representation of text document and by applying different kind of machine learning and deep learning based methods. Okay. Somebody asked, what is the difference between classification and clustering? I told you in classification, you have the target classes known. In clustering, you don't have the target classes known. So this is unsupervised, whereas this is supervised. So I'm telling you some example algorithms for document classification. So I picked up randomly some of the popular algorithms to showcase the entire gamut about classification, about clustering, about sentiment analysis, and so on. Now, what is document classification problem? The document classification problem is like this. Given a fixed set of classes, C1 to Cj, and a training set of labeled documents, I want to learn a function which can map every document in the document set to some class in the class set. So what I do, I learn from given data. What do I learn? I learn a function. And what is this function? This function tells me how to classify. And once I have learned this function, I can apply it on unseen data to find out what is the actual class of an unseen document. So it is something like this. Suppose we have documents projected in Euclidean space. So as you know, documents will be multidimensional documents, multidimensional vectors, so they can't be shown in 2D space. But let's assume that they are projected in 2D space. So all these documents that are appearing red, they are of class government. All these blue of science, class science. All these black ones are of class arts. Now suppose I get a new document and I ask you, can you tell me what should be the actual class of this document? So what will happen? I need to learn a classification for this particular data. So I need to apply a classification algorithm. And what will this classification algorithm do? This classification algorithm would be learning some kind of decision boundary. That this, anything in this side is this class, anything here is class 2, anything here is class 3. And based on where this particular document lies, we would assign it to one particular class. Okay. So we learn a decision boundary. And there are different algorithms to learn this decision boundary. So some of the popular ones are this: naive Bayes, K nearest neighbors, Rockio's classification, support vector machine, conditional random field, logistic regression classified. There are a lot of classification algorithms. Each one have their own pros and cons. Now out of this, naive Bayes is a probabilistic classifier, whereas rest of the three are vector space classifiers. So in order to apply naive Bayes, you don't have to represent the documents as vectors, but bag of words itself is sufficient. But in order to apply any of them, you have to represent them into vectors. Okay. Now let's look at naive Bayes first. So naive Bayes, as I told you, is a probabilistic classifier. So what we do is we compute, given a class C, what is the probability that this document belongs to class C? So this is conditional probability, and this is computed by two values. One of them is called prior probability, the other is called posterior probability. Okay. Prior probability is computed by a priori without looking at the data, and posterior probability is computed after looking at the data. Okay. And as you see here, PCZ is the prior and PTKC is the posterior, where TK is the term K. Okay. So what we do is we say that this document, the goal is to find the maximum a posteriori class. What is maximum a posteriori class? I look for that argument C, which maximizes this particular value. So what I do? Suppose for a given document, I have three target classes. So what do? I compute PC1D, PC1, PC2D, and PC3D. Now, whichever 1, 2, 3 maximizes the value, I will say that it will be assigned to this particular class. So I'm looking for that value of C, which maximizes this probability value. So in actual application, what do is we convert into summation, and what essentially we compute is these two values. We compute prior probability. So prior probability of a class is the number of documents of that class divided by the total number of documents in the collection. So this is occurrence frequency. So suppose you have two classes in a collection where one class has 80 documents, the other has 20 documents, then any new document coming would have a prior probability of 80%, 0.8 to go to class 1 and 0.2 to go to class 2. So this is how we compute prior. And what is posterior? The posterior is computed by looking at the terms. That what is the total term profile for a class and what is the given term profile for a given document. If this term profile is more relevant to the given term profile of a class, then this relative value would be higher. Okay. So the algorithm is something like this. We extract the vocabulary from the document. We count the number of documents. Then for each class, we compute these calculations. For all documents in this, we compute prior, we compute the text, and then we compute the posterior values by conditional probability. And finally, we'll have the vocabulary, the prior values, and the conditional probability values. And then for any new data, I pass on the prior conditional probability and D, and I have the class and V, and I compute these probability scores. I'm showing you with an example that makes it more clear. Again, this is a toy example because, in a small slide, I can only show you a toy example. Suppose I am given a training set of 4 documents. In these 4 documents, 2 documents belong to class C and 2 documents belong to class J. And these documents, as you could see here, they are very small. First document has only 2 words, second has 3 words, third has 2, and fourth has 3 words. And finally, I have a test document for which I need to determine whether this will belong. So there is a question mark here. I need to determine from the training, from the learning, is that what is this class? Whether this belongs to class C or this belongs to class J. Let's imagine that C stands for China and J stands for Japan. Okay. So how do I compute? I have to compute probability of D5 for C and probability of D5 for J. So these are 2 values that I need to compute. And how do I compute it? I compute it by prior multiplied by posterior. Okay. So this is prior multiplied by posterior. Prior multiplied by posterior. So how do I get here? What is prior? Prior probability is NC by N. Okay. So what is the prior probability that document 5 will belong to class China? 1 by 2, because the prior probability of C is 2 by 4, the prior probability of J is 2 by 4. So both of them are 1 by 2. So we have 1 by 2 values here. Then I have to compute what is the probability that Taiwan belong to C. What is the probability that Taiwan belong to Japan? What is the probability that Taiwan belongs to C? What is the probability that it belongs to J? What is the probability that Sapporo belongs to C? What is the probability that it belongs to J? Okay. And how do I compute it? I compute it by this. Count the number of words in that class plus 1 divided by count C plus vocabulary size. Okay. And what is it? Now see here. Taiwan. How many times does it occur in the documents of class C? In the first 2 documents, how many times does it occur? 3 times. But how many times does it occur? Sorry, not 3 times, 2 times. Taiwan here and Taiwan is here. So what do I do? 2 plus Laplacian correction 1 divided by what is the total number of distinct words in class C? 5. And what is the total number of distinct words in the whole collection? 7. 5 plus 7. Similarly, what is the probability of Sapporo? Sapporo doesn't occur in C. So it is 0 plus 1 divided by 5 plus 7. So 1 by 4, 1 by 12. Then probability of Taiwan, we compute in a similar manner. What is the probability of Taiwan belong to Japan? The prior is 1 by 2. The posterior is, how many times does it occur here? 1. 1 plus 1 divided by, what is the total number of terms here? 5. And what is the total number of distinct terms? 7. 1 plus 1 divided by 5 by 7. 5 plus 7. So this is 1 by 6. This is 1 by 4. Now see here Sapporo. Sapporo is occurring twice in J. So we have P Sapporo J 2 plus 1. 5 plus 7, 3 by 12, which is 1 by 4. So what do I get? I get probability. In order to compute probability of document 5 to belong to China, I compute the prior, which is 1 by 2. Then I compute P Taiwan C, P Taiwan C, P Sapporo C. What is P Taiwan C? 1 by 4. What is P Taiwan C? 1 by 4. So 1 by 2 into 1 by 4 into 1 by 4. What is P Sapporo C? 1 by 12. So I get the value as 0.0026. Similarly, I compute the other value and I get 0.0035. Now, which class this document will belong to? This document will belong to class J because this has a higher probability value. So you just need to give a little amount of time, just sit for 5-10 minutes, in calm, and you will understand it very, very nicely. What is prior and what is posterior? Prior is very simple. Prior is the occurrence frequency of a class. As you see here, you have two classes, both of them have two documents of each type. So 2/4, 2/4, 1/2 each. Posterior is when you see the data and then you compute probability for each term. That is called posterior probability. Okay. This is another example that is for you to try. First try, and then you have a solution for this. Now in this case, I can tell you some things. Here there are 4 training documents. 1 belong to class football and 3 belong to class cricket. Now if I ask you what is the prior that this 5th document belong to class cricket, this would be 3/4. What is the posterior? What is the prior that this belongs to football? It would be 1/4. Okay. So this is prior. And then we do what? We compute posterior. So we compute what is the probability that India belongs to C or football. Sachin belongs to cricket or football. India belongs to cricket or football. Japan belongs to cricket or football. Okay. So all of them, all these values are calculated. So all these are calculated, and based on that, we choose a class. So I compute PD5C, I compute PD5F, and whichever gives me a highest value, I assign it to that particular class. So this is naive Bayes. I'm telling you another popular method, which is very, very simple to understand also. This is called K nearest neighbor classification. What I do is, in order to classify a document, what I do is, given a document, I will assign this document to a class which is a majority class in its neighborhood. So what I do is, I look into its neighborhood. Okay. Now, what is its neighborhood? Generally, so here you have value of k is equal 6, but normally we keep the value of k is equal odd. So k could be 5, k could be 7. We keep it as odd to avoid ties. But let's assume that k is equal 6. Now, what do? I look at the 6 nearest neighbors. 6 which have the least distance from this. But what is the notion of distance? Distance is 1 minus cosine similarity. So when I say 6 with the least distance, I mean 6 with the highest cosine similarity. So in order to find out the 6 with the highest cosine similarity, you need to compute cosine similarity of this document with every document in the training in the set. I need to compute cosine similarity with all, because only then I will find out which are the 6 closest. Okay. Because I don't have a diagram where computer doesn't have a diagram where it can see and it can tell that these are the closest. So it will have to compute cosine similarity of this document with all the documents. Okay. And then what do? I say the probability of this document belonging to class government, belonging to class science, belonging to class arts. What is out of 6 neighbors? How many are class government? 5. So 5/6 is the probability that it will go to class government. Because I'm looking at the nearest neighbors. Okay. It will work. This Euclidean will work on the document vectors also, because we are computing cosine similarities, and cosine similarities are single values, scalar values. So if you compute cosine similarity of this with another one, then this would be a scalar value. Yeah. Similarly, what is the probability that this belongs to science? Out of 6 documents, how many belong to class science? This is 1/6. What is the probability that this new document belongs to class arts? This is 0 by 6. So this is a very simple algorithm. It is a vector space classifier. What we do is, in order to compute the probability of belonging to a particular class, we compute the probability by looking at the neighboring documents. So what we do is we find out the most similar documents to the given document, and then we compute probabilities. Okay. There is another variant to k nearest neighbor that is called Roorkee's. In Roorkee's, I'm coming to that, but I will explain you right now. So what is the disadvantage here? The disadvantage here is that you have to compute cosine similarity of this with all the documents. And every time a new document appears, you have to do it again and again. But a better approach would have been this. Sorry. A better approach would have been where you already know what these classes are. Class 1, class 2, and class 3. Okay. Then do not compute the cosine similarity with all, but for each class, compute a prototype vector. Compute a vector which is known as centroid vector. What is a centroid vector? Centroid vector is like an average value. So what is an average vector? Average vector is you add all these 4 vectors and divide each value in the vectors by 4. You add all these vectors and divide each value in the vector by 6. You add all these values and divide it by number of vectors here. So what do we get? We get new vectors. So this is a centroid vector, this is a centroid vector, this is a centroid vector. Now suppose I get a new document. What do I need to do? In Roorkee's, I will only compute the cosine similarity. Sorry. I will only compute the cosine similarity between this centroid document and this centroid and document and this centroid. So how many cosine similarities I am computing? In the Roorkee's, what I was doing order of n computation for computing cosine similarities. Now here we are only doing 3. Assuming that centroids are pre-computed. Okay. But so centroid computation is required only few number of times. Every time the membership of a class changes. Okay. So based on whichever centroid has the highest cosine similarity, this document will be assigned to that particular class. So this is called Roorkee's classifier. So there are 2 vector space classifiers that I just told you, KNN and Roorkee's. In KNN, we look at k nearest neighbors, and in Roorkee's, we look at similarities with prototype vectors, which is called centroid vectors. So I'm skipping all these slides. You can look at it later. Then we have another problem which is called document clustering. In document clustering, you may have heard about k-means clustering. It's a very popular clustering algorithm. What we do is, in documents within a cluster should be similar, and documents from different clusters should be dissimilar. So this is a common form of unsupervised learning. Now, as you could see here, if this is a 2D projection of documents, you can very easily tell that this is cluster 1, this is cluster 2, this is cluster 3. But in actual practice, while doing it by an algorithm is a challenge. So there are a lot of applications for clustering. For example, one popular example could be something called vertical search. Now, suppose you searched for text clustering, and your search engine, out of all the results that you get, it automatically clusters them by topics. It tells you that out of 187 results, 30 are about mining, 19 are about gene, 13 are about clustering algorithms, and so on. Now see how efficient it has made your search process. You can click on one of them if you're interested in mining. If you're interested in mining, then you click on this and rest of results would be removed and you will have only 30 results here. So your search is refined further. So clustering can be useful here. There are different kinds of algorithms. Clustering can be divided into flat and hierarchical. In flat, you divide in a manner that each document belongs to only one class. In hierarchical, a document may belong to different hierarchies. There are two variants, bottom up and top down. Bottom is called agglomerative and top down is called divisive. So you simply read it. They are very simple to understand. Or we can say hard clustering or soft clustering. In hard, a document is permanently assigned, just as we have in crisp set. In soft, it is assigned in a fuzzy manner, just as we have in fuzzy C-means clustering. So I will show you one example just to show you the algorithm. This is called K-means algorithm or partitioning method. So suppose we have a set of n documents and I want to cluster them into k groups. Suppose we know in advance that there are k different types of documents, k different groups of documents. I want to find out an algorithm which can group all these n documents into k different groups in a manner that all of them which are similar are in the same group. So in order to do this, we need to understand what is the centroid. I just told you, you sum the vector and you divide it by the number of vectors in that group. That becomes your centroid vector. So centroid is always for a group. Okay. So what is the algorithm like? The algorithm is you select k random seeds. If you have to group into k clusters, you select k random seeds S1 to Sk and then run an iterative process. Now, what is this iterative process? I will show you. Suppose we have k is equal to. Okay. Now, very clearly seeing what we have to do is we have to select any two random documents as my seeds. Randomly, any two. Suppose I pick seeds and randomly I picked up this document is my seed 1 and this document is my seed 2. So this is seed 1 and this is seed 2. Okay. What is the next step? I assign the documents to reassign clusters. So what I do, I compute the distance of each document with both seeds. Okay. Distance of this with this, distance of this with this. Now suppose this document, if this is close to this one, this will be assigned to this class, which is the case here, because this has become red. And this document, it is farther from the blue one, so it is not assigned to that. But this document, because this is closer to the blue one, so this is assigned to the blue class. So as you see here, what we have done, we have initiated with two random seeds, and then we computed the cosine similarity, and based on what is the cosine similarity, I assigned each document to a class. But what is this? This is a random solution because I randomly picked up two seeds. Okay. This is not the end. I iterated. Now, based on the class centroids that we have created, based on the classes that we have created, I recompute the centroid. So this is one group, and I compute that the centroid is here. This is another group. I compute the centroid to be here. So I have recomputed the centroid. What is next step? I'm going to reassign clusters again. As you see here, these two documents, they are close to this centroid as compared to the red centroid, so they have become blue. So what is my solution now? I'm just iterating. I initiate with a random solution and I'm iterating, and my first cluster is this. My second cluster is this. This is my centroid. This is my centroid. I recompute centroid. The centroid moves to this place. I reassign. No change happens. I recompute. I reassign. I keep on doing this until my method, my algorithm converges. Okay. So this is how we compute. We keep on running, and this is called k-means. clustering. Now, what is a convergence criteria? Either the partitions do not change, or you have computed a fixed number of iterations. So either a fixed number of iterations is completed, or document partitions remain unchanged, or centroid positions do not change. They are more or less same. Now, what is a good clustering? Well, we need to evaluate. So there are two measures, intra-class and inter-class similarity. Intra-class similarity should be high, inter-class similarity should be low. This is an internal criterion, but often internal criteria does not work, because if you divide k is equal n, then that gives you the best residual sum of square value. So we use an external criteria which is called purity, and purity requires that you know the actual class. So these are three clusters, and I know the actual class. I know that these 5 are red class, this is blue. So you cannot compute purity unless you know the actual labels. And based on this, I compute the majority. So this is 5 by 6. Purity of this cluster is 5 by 6. Purity of this cluster is 4 by 6. Purity of this is 3 by 5. So this is clustering. And I come to last one, and I think I am going to take another 5 minutes. That's all. On sentiment analysis. And then I will break. I will stop it and it's open for any discussion or questions. Now, what is sentiment analysis? I told you sentiment analysis can be done at document level. It can be done at sentence level, or it can be done at an aspect level. In document level, we work with one topic, one object assumption. That the whole review is about one particular topic. In sentence level, we assume that we are talking about multiple topics of the same subject. So one sentence may be positive, one sentence may be negative. In aspect level, we say that we may be talking about different aspects of the same thing. For example, for a mobile phone, in a review, we may be talking about its battery life, its screen quality, its price, its touch screen, and so on. In sentence level, we classify. So any machine learning classifier can be used for document level sentiment analysis. Any machine learning classifier. So this is a document review. If you know, this would largely be classified as positive. This is, as we see, most of the things are negative, but some of the things are positive also. This is another review. Few things are awesome, tremendous. Some things are disappointing. So the best representation would be either you do sentence level, where you say, I bought an iPhone a few days ago. It was such a nice phone. The touch screen was really cool. The voice quality was clear. So all these are positive. This is neutral. This is neutral. But all these are negative. However, my mother was mad with me as I did not tell her before I bought the phone. She also thought that the phone was too expensive. So for each sentence, you may have a particular... Something started here also. Anyway, so you may have a particular label as positive or negative. Or we may go a level further. We may go feature based. For example, touch screen was good, voice quality was clear, but battery life was not good. So if I give you 10,000 reviews of this kind, can you summarize me? Can you give me a summary by a program? So this is what I'm asking you. Suppose I give you 10,000 reviews of a mobile phone, and I ask you to give me a picture of this kind. This is nothing other than feature-based sentiment analysis or aspect-level sentiment analysis. So what I do is, in these 10,000 reviews of the cell phone, I locate what is being said about voice, whether that is positive or negative. Over all these 10,000 reviews, I extract the features, I extract the opinion, and then I rate its polarity. So as I could see, voice is largely positive in most of the reviews. Screen, most of the reviews are positive. Battery is slightly negative. Size is most of the reviews are positive. Weight is more positive, but it's a mixed opinion. So just imagine how easy it is for you to decide whether you should buy a cell phone 1 or not. Not only this, if you're not clear, if you're not sure whether you should buy cell phone 1 or cell phone 2, you can do a comparison for both in the same figure. So you can do a feature-based sentiment analysis computed in both. So as you could see here, cell phone 1 outperforms cell phone 2 on most of the features, so you can very easily go for cell phone. So this is called aspect level sentiment analysis or feature level sentiment analysis, and is a very hot topic of research nowadays, and is a very challenging topic also. Because how do a computer system knows which word is a feature? And even if it has known, how do we locate opinion about that feature? And once we have located opinion, how do we compute polarity, whether it is positive or negative? So there are three challenges. So sentiment analysis, you can use either a machine learning classifier for any of them, or you can use a lexicon-based approach, which uses certain dictionaries. So dictionaries are used for this particular purpose. SentiNet, SentiWordNet, these are popular dictionaries. I'm sure some of your topics, some of your classes will have a talk on sentiment analysis. I'm just closing by giving you some important, useful tools to play with. You go to uclassify.com, you cut, paste, copy, paste any review, and it will tell you positive, negative. It will tell you the mood of the writer. It will also tell you whether the writer is positive or negative. If you are more interested in a more challenging task, then you can use Alchemy API, which allows you 3000 free hits a day. So the Alchemy API allows you to have document level, sentence level, and aspect level sentiment analysis. So you don't have to code everything on your own. You can use Alchemy API in your program. Now I'm showing you a picture. As you could see here, everybody is a person except this Arthur. Now Arthur is a humanoid robot which has the capacity to converse in English. And not only converse, it also expresses emotions. It can, because it is programmed to express the external correlates of emotions. It can, if you tell a joke, it will become happy. If you tell a sad story, it will become sad. So it is programmed. It was part of my Indo-Mexican project that we did in 2013, 2016. We bought the robot, but most of the natural language processing part we did, particularly sentiment analysis, and this part we did on our own. And this was programmed to express emotions. So this is called a humanoid robot which can express emotions. If you want to read more about sentiment analysis, these are some initial papers on sentiment analysis, but still very good ones, very popular ones, and few new ones, some of our own work on sentiment analysis. So I just conclude by saying that huge volume of unstructured data is being generated, which can be tapped for useful inferences and decisions. But processing the large volume of data needs automated models. Unfortunately, statistical learning methods are being increasingly applied for data understanding and processing. And the new hot buzzword is deep learning. Because now almost everybody is using deep learning model, even if they can't explain how this is working, but people are using deep learning models. Now that there is also a demand for explainable AI, where people demand that the model should be explainable also. Not only that they should give good results, but they should also be explaining. So this is all that I wanted to say. Thank you very much. If there are any questions, I would be happy to take, and I would be sharing the slides just after this with Dr. Jyoti, and I'm sure you will get it from me. Thank you very much. I'm stopping the sharing.
Thank you, sir. And this session was really informative, and I think people got enough knowledge, and it was fruitful for the participant. Okay, so with this we can thank sir, and
so thank you, sir. Really, thank you with going through such. I was not knowing that you and your family had such, but I hope that all are well now.
Yeah, everything is all right. Thank you. Thank you.
Now. So it's really and we are really grateful, sir. With all the odd situation, you took 2 hours of classes, and the participants. Any other question? Already you had some discussion with sir, but I had to disallow. In fact, I initially allowed each participant to unmute and ask so that it become interactive, but due to some trouble, I had to disable that. So now I have enabled the participants to ask their questions. So if you have anything to discuss with sir,
Yes, sir. Sir, Vivek, sir. Hello.
Yes, Mr. Naveen.
Yes, yes. Vivek, sir, like you were talking about feature-based analysis, and you said that some research is being going on this. Okay, so sir, can you please elaborate on that? What is feature-based analysis? You showed that slide where visualization was there based on comparing two mobiles, right?
Yes. So feature-based sentiment analysis or aspect level sentiment analysis is the most useful one, because what we do here is we process a review and then we extract certain words. These words are called feature words and these feature words are then classified into a feature class. So what we need to do is we need to identify what is an aspect word. Then we need to identify to which aspect class this belongs to. For example, for a mobile phone, screen resolution may be a class. Battery life may be a class. Price may be a class. And then you have to find out that what could be the words which can express price, or what could be the words which can express screen resolution. So you need to identify words, you need to classify them, and once you have classified them, then you have to locate opinion on that particular feature. You have to find out that what is being said about that particular word, and finally you have to compute the polarity of that sentence. So based on that, you will say whether this word is positively rated or negatively rated, and then finally you aggregate this over all the multiple reviews. So there are multiple ways to do it. In fact, people apply machine learning for all the tasks, even for identifying whether the word is a feature word or not. And similarly, to classify whether a word is positively rated or negatively rated, people can use machine learning or they can use some kind of dictionaries. So there's a huge amount of research in sentiment analysis at feature level, and you could refer to a lot of things. There's a lot of publications in knowledge-based systems, in KDD, in ISGAI, in Coling, in ACL. So there's a lot of work in sentiment analysis that you could refer to.
Okay, okay. Thank you very much, sir.
Sir, I would like to ask myself, Srihar Shatri. Sir, can I ask the question now?
Yes, please go ahead.
Okay, sir, my question is on the text to vectorization. Sir, I have a doubt that if I want to convert some sentence into the vectors, then what should be the length of the vectors? How to give the input to the neural networks? Because some sentences are of 4 words, some sentences can be of 10 words. Then how to make the normalization in this while giving the inputs to the neural networks?
See, when you vectorize, you normally vectorize it with respect to a document collection, with respect to a number of documents, not only for one sentence. So suppose you have, even if you have a big document that comprises of 1,000 sentences, you have to extract the vocabulary first. And whatever is the size of the vocabulary, that becomes the size of your feature list. Or you may reduce the features by selecting specific POS tags. You may say, okay, I am only looking at noun words. So you can do POS tagging and then you can say, okay, I am limited only to noun terms. Or I'm limiting myself to noun plus adverbs or noun plus adjectives and so on. So there are different ways of, depending on what is the problem that you're working on, your feature vector would be decided.
Sir, one more in the continuation of that. Sir, if we work in the machine translation, then we need all the aspects like noun, pronoun, adjective, verbs. Then how this neural machine translation happens?
Well, I'm not expert of language translation, but what I understand is that in that cases, you will have to store. So neural machine translation happens by a lot of things. We not only capture the words, but we also capture the context of the words. So we look at, preceding words, we look at succeeding words, and we look at patterns, and then we look at the equivalent patterns. So we say, okay, this word is occurring with this preceding word and this succeeding word. So this should be substituted by this particular word. So there are many such combinations that we work on.
Hello, sir.
Sir, adding to that, actually, we use a encoder decoder sort of structure. So we have one LSTM going which is taking input, and in fact what sir told, it's encoding that information in a latent space, and then from that latent space there is a decoder which normally takes that or basically converts it to the target language. That's the standard nowadays in almost neural translation.
Can I get an opportunity to ask one question, please?
Hello?
Yeah, sir.
Yes, I want to ask, in most of the algorithms which are explained today, cosine similarity has taken as a basis. Okay, so is the major basis for classification or clustering in every application of NLP?
No, not at all. Cosine similarity is not the only similarity. There are at least 10 to 12 popular similarity ones, but cosine similarity has become a kind of de facto in the sense that it is very, very popularly used. So I couldn't explain so much in a in 2 hours time where I had to cover a lot of introductory things. So I have just picked out one which is most popular one. So there are many other similarity methods.
Yeah, okay. Okay, thank you so much.
Sir,
Nice
I have a
explanation.
Excuse me, sir. I have a question, sir. I have a question, sir. Am I audible?
Please, one by one, and I think already it's 6 o'clock. So it will be better if you just write down these questions.
Sir,
and,
last question, sir. Last question, sir, please. I'm having last question. One question, please.
Okay, okay, please go ahead.
Can you please name some data sources from where we can get the real-time data to apply feature-based sentiment analysis?
Well, why not? There's a lot of data on this. You pick up SEM eval challenges. SEM eval would be the best source. And if you want to get some data, look at the challenges that are there on Kaggle. So there are a lot of challenges that you can pick.
Kaggle's data is already fixed. I want to get the real-time data sources. For example, take example of Amazon, Flipkart.
You can write your own parts. What is called as grabber. You can grab those data directly.
You can grab, but who will tag that?
Yeah.
So that is why, when we work on an algorithm, we work on a standard data set because we need to have the relevance judgment. We need to have the gold standard available. So that is why once you are clear that your algorithm performs good, then you can apply it on real world data directly. But you are never sure that, your algorithm working good on one data is going to work equally good on another data.
Okay, sir. Thank you very much.
Okay, sir. So to participants, you can obviously write your questions and we would like to answer those. Sir had already, he was having whole day meeting, and then with all the backgrounds, I think all of you have heard that. So let us say a thank from our heart to sir that he really give an excellent talk and as well as discussed with all the participants. And as I can see, a lot of praise and lot of thank you to you from the participants, not only from me. A lot of thanks you I can see in chat window. So really, it's thank you, sir. Thank you so much.
Thank you very much, Dr. Jyoti. It was my pleasure. Thank you very much. Thank you.
Okay.
So I'm just sharing the slides with you. You can make it later.
Okay, sir. You can send me the slides and I will share it.
Sir, I have one question, sir.
Yes, Akars.
Sir, I want to ask about the vector form as you have given some knowledge about that, sir. Can the data sources can achieve the tensor form also? Like if it is accepting the vector space form, then it can be denoted as a tensor form.
Yes, why not? When we give it as CNN, we normally give it as tensor only.
Yes, sir. Because it is using more than I think more than 2 or 3 subspaces. So it can.
Yes. That's what I'm saying, that when we give it to CNN network, basically convolution neural network, it is already 2D, 3D.
Okay, sir. Thank you, sir.
So one day convolution is performed, but the input is more than that. Okay, so we can end this session here. In fact, if you want, even I can, whatever knowledge I have, I can share with you, those who are interested. I think I had to cut short of some of the questions, so we can discuss over that. So if you want to, please suggest some research topic. Now, there are a lot of research topic on NLP. Sir had already suggested like multi-document summarization, aspect level, say sentiment analysis. These are no doubt very good topics. Now, summarizing a lot of topics are coming. So summarizing that text and then giving to the user a very small, concise form from multiple documents, like a lot of documents coming from say the disasters area, and you are just summarizing that again there is a very limited work. Sure, I will share the slides. As I have told that we will share already. If you are on the canvas, you can see that we have already shared 2 days lab materials. So already the data as well as the IPNB file, the Python code file is already shared on Canvas platform. Similarly, we'll share all day slides, data sets if we are requiring in that demo session. So everything we'll share it over the Canvas platform. So make sure that you are accepting that Canvas link. If some of you are still missing, you just send it. Whosoever have sent it to my WhatsApp, that shared WhatsApp, I have already created. So just send your name and email ID through that WhatsApp link. I am just creating. It will be created.
Sir, can we get the recording?
Yes. Recording will also be shared there only. Because now we are following one platform. So I will share all this recording, etc. in the Canvas platform only. So that will be the hub where you can get, except this video, the live video, which is going on. Everything else you can get in the Canvas platform.
Thank you, sir. Sir, what should we do for the next session?
There will be that will be a demonstration session. So we will be demonstrating you whatever how we can go ahead with the say NLP problems, how to tokenize and how to take a data, get rid of some unnecessary material, pre-process it, and so on. And we have already, as I told, I have already shared the data set. The expert will start at 6:15. So if you have your own laptop,
same link? Is it on the same link?
Same link means?
Is it on WebEx?
WebEx, yes. This link will remain same.
Okay, sir. Thank you.
Question on how to make summarization model. Is it supervised or unsupervised? Say that can be model. Now, summarization means finding some important sentences from a document. Now, how you are finding that important sentence? People have tried it through clustering models also. People have tried it as unsupervised way. That means say classification model says model also. So it depends on how we are framing that problem, which is important and how to find out those important sentences. And
Sir, please send Canvas link, na?
Lab will be in Python. Dr. Sriparna will be an expert in that summarization. She had done a lot of work and we have a separate session on that. Document summarization, I think we have already shared. So you can wait and you can get a lot from her.
Sir, I'm not on Canvas, sir. Please send the link on the WhatsApp group.
So say Naveen Baswani have already created. You please check. You have not checked the mail ID.
I have checked mail ID, sir, but I'm not
I have
receiving
not got
Canvas.
any mail. I just checked it.
I have told that some of you might not have got, or some of you might have not accepted 2 days back. So now it is now finding difficult. So what you can do, you can just send me your name and mail ID on that WhatsApp, and we are creating it. Okay.
Okay, thank you, sir.
So regarding Hindi translated data set, as sir told, I am also just highlighting that there are several conferences and they release data sets like REC, LREC, FIRE, Forum for Information Retrieval. They share this sort of Hindi, English, Dravidian, Arabic, several languages data set they share. They held a competition and then those data sets are free. So you can get and you can even participate in those ones. So I will highly encourage everyone, those who are participating here, to track these conferences like Cooling, FIRE, ACMC GAIAR, and there you can get a lot of data sets and lot of discussions on these topics. I think we have already shared an attendance Google Sheet for that.
When the second session is started, sir?
It will start at 6:15.
So
Within
Google Sheet
a
where?
Google Sheet was
Sir,
shared to all of you.
sir, I have checked the canvas right now, sir. There is nothing about the what the VXR slide I was speaking about.
Huh?
Sir, I had right now checked the canvas, sir. There is nothing like slide or the recording of the session.
Say the recording is still going on. How can I share this recording right now?
Okay,
Recording will be
sorry,
obtained
sir.
only after the session will be over. And regarding
Uh,
slide, you just the presenter had just finished. And after he has finished, I am constantly in talk with you. What I told, I do not told that recordings and these things are available. I told that today's lab materials are available.
Sir, I have not received the canvas link.
So just send those things in WhatsApp. If you say something here, how can I create that link? Please wait and send that, and please wait. We will be creating that.
Okay, fine, sir.
Okay. And this, whatever material we will share it for whoever. Canvas links will be live, and you can always access this material.
Excuse me, sir.
Okay,
Sir,
someone has
myself.
already shared the labs concessions.
Hello.
Hello? Hello? Hello, sir.
Yes, yes.
Sir, which algorithm is best suited for text classification? Like we have many algorithms like SVM, k-nearest neighbor. How to choose that this is the best algorithm?
It depends on your data set.
Nowadays, everyone is trying for LSTM or CNN model.
Yes.
To be very honest, machine learning algorithms are now, they have their own limitations. So people are now mostly going with that.
Okay.
With CNN or LSTM models.
Okay.
And so for fake news detection model, so where we get the data set?
You can go to Kaggle. You can. There is some data
Like,
set.
I think Dr. Akshay will be taking session next. He had already worked on that data set, so he will be a better person to talk about this one. He can give you really some links. I have not worked on that data set.
Like, sir, I got a research like we can go get the data from worldwide key, jo real time data. We can also take that and make a model on.
Yes, you can get, as I told, no, you can always crawl. We call it as crawling. So you can always crawl the real data set. But the question will be how to validate that, whether it is good or bad, whether your model is working.
Yeah,
really well.
Labeling the data set is a problem.
How to label that?
Okay.
Sir, what are the text processing tasks that are required for disambiguation?
So,
your voice is very low.
Sir, what are the text processing tasks required for disambiguation?
Disambiguation is said.
I have not worked, so I can't comment too much on that. So please wait. Dr. Asif will be taking some sessions, and if you put this question to him, I think he will be a much better expert for this. So keep your question, and I think next week we have Dr. Asif or Dr. Sriparna. And
See, Elmo model, Elmo embedding model can help you.
उसकी फोटो है पर है कोई और बोलते हैं कहाँ गया था कुछ याद अच्छा
Good evening, sir.
Yes.
Sir, this is Jyoti from UCV, Vijayanagaram. Sir, please add me in the WhatsApp group, sir.
I have sent the link for WhatsApp group. You can click on the link. It will join you to the group.
Okay, sir.
Hello, sir. I had a doubt regarding topic extraction. So, how to validate topics extracted from a document?
See, when normally if we go to supervised learning, no, we already have extracted documents already there. So some topics already there.
No, in
And then
unsupervised learning, I mean, in unstructured text,
when
extracting
in
topics from a.
if we check the cases that whether we are right or wrong, people take something which is already really labeled, right?
But
How to test?
Yeah, in domain specific, how to test topics which are extracted from an unstructured text.
See, again, what sir is saying is what Vivek sir also said. Either if you have a text, then you must have a gold standard that somebody would have labeled that these are the topics corresponding to this text. And then whatever model you're doing or proposing, you should be able to validate against that, that this is my model, whether this model is able to extract the required set of topics or not. Okay, whether it is structured text or unstructured text. So that is what it means by labeled data. Now, if you don't have labeled data, then you have to either label it manually, or you will then sort of define some sort of metric that how related my topic is with the with the original text, some sort of similarity metric. But generally, when you have a data, you have a set of topics which are extracted, and you match against them.
Okay, so statistically, it's not possible to test the topics, right?
Statistically, you can just like we do, we do in text summarization, we compute the similarity of the summary with respect to the original paragraph or original text and see, how relevant the extracted summary is. So in that way, you can come up with metrics, similarity metrics, that whether this topic, how many times it appears in the original text, or how similar it is based on some similarity metric. Some sort of metric you can come up with. But again, because it is not labeled by human, that this is what the topic extracted should be, so it cannot be relied upon. Right? How will you justify just basis on some statistic? It becomes difficult to justify that this is it.
Yeah, actually, we have a use case in our company, and I'm working on it. I mean, on extracting topics from like huge unstructured data. So
See, that is fine, but
I had this
eventually
doubt.
have to label it, right? Somehow, how will you measure? So otherwise, you can define similarity metric, something along those lines. That if I'm extracting a topic, then it should represent that. But how will you define that representation?
Yeah,
It
but
can be
problem
similar.
is it is coming from different domains and it requires domain expertise. So
Yeah, so that much you'll have to do because how will you validate? Even if you extract,
Right.
let's say even if you define some similarity metric, you extract that. How will you know what is actually good in real life or not? You need a human, right?
So it's kind of getting feedback from the customers.
Yeah. So you'll have to either, you can define a sort of an automated system based on similarity metric. And then whenever you suggest a topic and you ask your customer, is this a relevant topic? Do you think it is relevant? Yes or no? And in the process, you build your labeled data set and your model improves. That can be one way.
Thank you, sir.
I just also want to add one more point here. This is Dr. Rajiv Bajpayee. So you have rightly said that we need to annotate the data properly, but there is always a human factor is involved in annotation of the data, which you were mentioning about this labeling of the data. So whenever any human is going to annotate or label the data, even after annotation, we need to do the validation. Otherwise, that particular human factor is going to create some problem. So for example, like let's say there are various e-commerce sites and there are multiple vendors who are uploading their products on different e-commerce site. So when the particular vendor is coming from a particular geography, there is a particular human factor is involved. So let's say, for example, you are trying to sell a product that is having a neutral gender, but maybe because of that human factor, it will tag as a male or female. Then there is a problem started. So we need to validate that as well.
Yeah, and it can be subjective also if different people are labeling it.
Right.
Perception can be different. Yeah.
Right.
Got it. Yep. Thank you.
Okay, so let me introduce our next expert. Dr. Akshay Deepak is going to handle the next session, which is a demonstration session. He's going to show you, the basics of NLP, how to do different operation in using NLTK using Python. So he is a assistant professor at NIT Patna and have experience in NLP and bioinformatics. So let's welcome Professor Akshay Deepak sir. Sir,
Yeah,
you
thank
are a
you, sir.
presenter now. You can share your screen also.
Okay, so thank you, sir.
Just to add to Akshay sir,
Yes, sir.
we have already shared the material what you have given to me.
Okay, okay,
We have shared it through the Canvas platform.
okay.
That I expect that is available to most of them. Some might not have because their Canvas link is not working. We are working on that.
Okay, sir.
You can expect that say around 80% of them will have that data set available to them.
Okay. So just in case, I'll just put it on Google Drive and then share the link to all of you on chat box. So meanwhile, while I'm sharing, so this session, because it's the first session, and so this will include basic introduction to Python, and then introduction to NLTK library and the common tasks that we come across. Now, before I go ahead, some of you may shoot that all of us know Python. So this may not be the case. So while going through basics of Python or basics of NLTK, some of you may already be aware of it. So it's good. It's all right. So in that case, you can pay less attention to those things, or you can, skip that part. And because we are dealing with a wide audience, and a lot of them may not be aware of this is the first time they may be, getting to know about Python. So we will introduce Python. And then in the second half, we will introduce, we will do the basics, of NLTK, the processing tasks, and so on. Okay. So just one sec. So I'll be assisted by my students, PhD students, Ashish and Vikas. They'll be doing the demonstration, and I'll be there online. Just one sec. I think I've shared it. Okay. Yeah. So I'm putting the lab material in the chat box. This is the Google Drive link. You can download it from there, just in case some of you did not get the Canvas link. Okay. 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 So, Bhaskar sir, can you make Vikas a presenter as well?
Yeah, sure. Vikas Dubey or Kumar?
Vikas Kumar. Vikas, are you there?
Yes, sir. Vikas Dubey, I am.
No, Vikas Kumar.
I'm here, sir.
Okay.
So, sir, Vikas Dubey, Vikas
Vikas.
Kumar is your student.
Yes, sir. Vikas Kumar. Yes.
Email ID. Okay, Vikas Dubey, sorry, Vikas Kumar is now a presenter also.
Okay. Vikas, please start.
Thank you, sir. Hope screen is visual to everyone. So first of all, we will go to how we will create a Google Colab file. So for that, we will open our Google Drive. In Google Drive, when we click right click, then we have options what we want to create. So first of all, we will create Google Colab file.
So while we are doing this, ideally this would have been a lab session where each one, would have been here and done this. So it's a demonstration session. So what is expected from the participants is try to keep up, follow with what is being shown here. And we have already shared these files to you. So as we type snippets of code, you can either copy paste the snippets of code from the file that has been already shared to you, or you can just see what is being typed and then go along with the demonstration.
So this is
and in between, if you face any problem, you can just speak up, and so that we will stop and try to resolve your issue. Yes, please proceed.
So this is the page where we have to write the code, Python code. So here, this is the file name, which we can read as FDP session 1. And here, this is where we have to connect it to get connected with our drive, Google Drive. So here we will connect it like this. Then we have a code from google.colab import drive. Here from Google, we are importing drive functions. In drive, we will create drive
It would be better if you copy and paste it from the shared file. It would be easy for the participant to follow.
So one thing, like, how did you open this? I mean, I'm trying, but what happened?
Yes. So go to Google Drive. So Google Drive is just type on Google Drive. Can you show Vikas? That's just how to go to Google Drive from starting.
No, I can open the drive and the files. But how
Yes,
to open it?
there you have to, like here we are plus, where we have plus sign, then we go for the more, then we have a Google Collaboratory.
Okay.
Yeah. Then this page will be open, in which we have to mount our drive.
किलो उल्लीम 4 किलो
So can you
on the cover letter.
So this is the code where how we have to mount. After that, we will get a pop-up to connect with our drive. Here we have to click on connect to Google Drive. Again, we have to sign in with our email ID by which which drive we are going to connect. So here I'm using my email ID. Again, we have to allow to access the files. For that, we are using allow menu. In the meanwhile, it will be connected within a minute. So here, our drive content G drive is being connected. So here we have uploaded the data, the file and the data set. by which we can get the link. This is the way to copy the path. So this is the path where I have uploaded the file like example CSV sample text file, which we will use in coming sessions, in coming time. So from starting, I have shown you how to connect Drive to Google Collaboratory. Then again, we are using Python, like it's a general purpose, interpreted, interactive, object-oriented, high-level programming language, which can be used in portable and extendable mode. So first, we are printing hello world with the help of function print function. Here, it takes input as when we are inputting a text, it should be in the quoted form. So see, this is when we print this statement, when we run this statement, it will print hello world. Again, we have if else conditions, just to show you what happens here. True means if condition is true, it will print true, else it will print false. Here condition is true, that's the reason it's print a value true. So again, we are introducing you with the how we go with the function in Python and the class. For the function, we use define keyword, and then this is the function name, and this is the two argument we are using, like name and the age. For in the in the function, we are using print functions and print to print name and the age. Here we are calling the functions print info and passing the parameters. Here we are passing the parameter.
Like, can you explain them this increase the font size and show them the drive connection again? And
okay,
have we shared this file notebook with them, right?
Yes, sir, we have shared.
Can you just show them how to extract from the zip file the notebook and then import it in your collaborator?
So for that, we have to extract it in, I am using here WinRAR file. Suppose here, this is NLP Day-1 live session files. We are extracting using here WinRAR in the local system, and then we are uploading it. Then we are uploading it on the drive where we want to work. And again, so here we are using to connect our Google Collaboratory with the drives. Here we are using from google.collab.import drive. We are importing drive functions. In drive function, we are using mount to mount our drive to this path, content/G drive. Here, if we want to connect directly this part, we can put it here, and it will be connected. This file will be connected to this NLP Day-1 session, lab session folder. So here in the function Python, we are using print info.
So participants.
So we are using print function as a function, and in which we are passing the parameter name and the age. And again, yes, sir.
So participants have been given the permission to unmute themselves and ask questions or basically discuss. So it's not a session where, as Akshay sir has told, that we are not just trying to cover things. And if you are going through it and if you are finding difficulty, you are encouraged to discuss. But be careful that by chance you are not unmuted and talking with your friends. Because that breaches your privacy also.
So, basically, I downloaded the zip file and extracted it also.
Mhm.
It's, again, I'm not able to import it in this.
Vikas,
So
can you
if
show how to create a just in the Google folder where and
Actually,
then
I have also
can you just do it from scratch?
yes.
when I run the path, it is
I have
not
to upload the file on the Google Drive as well.
Okay. I will share.
Sir,
I
I
will
am
share.
also not able to set the path correctly.
Sir,
Yeah.
So participant, just a request that let that since someone has asked a question and he is going to demonstrate something, so please wait for something, wait for the time till he is doing that event, and then ask. We are not stopping you to ask your queries, but if all of you start talking with each other, it is not becoming possible for us to understand that. So please understand that.
Okay,
I
so
want to ask a question. Hello.
Yes.
Sir, can we do these codings in our VS Code editor instead of Google Colab or something?
Yes, it is Python code you can do whenever you want. You have to adjust the data files accordingly, place the data file in your local system. We are just going ahead with Google Colab because otherwise it requires explaining a lot of installations and so on, and updating the libraries and packages and it takes a lot of time. Yeah, so if you already have a Python IDE, this will
Yes,
work.
sir.
Okay,
Yes.
just go ahead and do it. So Vikas, can you just create a folder, just explain them, create a fresh folder, and then how to upload the Python notebook from the zip folder that has been shared with them.
Okay, sir. So
And then
first
run
of all,
Python from there. Yeah.
yes, sir. First of all, here we are creating a folder in Google Drive. Like we are creating folder like Vikas file. So here we have created a folder Vikas file on the drive. Then we have here zip file NLP Day-1 lab session. We are extracting it to NLP lab session 1. And again here, this is the extracted file.
Vikas, your sharing is only for the tab. It is not for your screen.
Okay, sir, sorry.
Can you share your entire screen so that people know where you're doing it?
sir, if so, it is possible, can that file be dropped to the WhatsApp group or something?
It has already been emailed, and I have shared the Google Drive link in the chat box. Anyone can access that file with the link. You click on the link, then on the right side, you will see a download. You'll see a download this thing button.
Sir, can you share the link again? I somehow got disconnected.
Okay, it is there on the chat box. I'll just type again.
So what type of libraries do we need for this?
Just follow. We'll come to the libraries part. It is everything is there in the code, and you don't have to download anything extra. That is the nice thing about Colab. Okay.
So we have created a folder on Google Drive, and here we have extracted the zip file, and this is the folder we have created. From that, we are uploading all these files on the Google Drive. So this file I have selected, I will be uploading on this by selecting and just slide. Yes, using drag and drop. So we will see that all the file have been uploaded on in my Vikas file folder on Google Drive, right? So here we have to create a collab file, IPYNB files. For that, we will right click on Google Drive folder and we will go for more. And here we have a Google collaboratory file. So this way we have created our first Google collaboratory IPYNB file, which is open in Google Chrome. So here we will first connect our this file to our drive. So that we will connect with the help of this, we will connect to the session. So this is connected, and here we have, and this file is connected to the Google time sessions. And again, we have to connect it to our Google Drive. For that, we are using this code. We are just copying and paste from Google Colab. We are using drive function. And
can you copy and paste the code from the file that has been shared with us? It will be helpful for the participants.
Yes, yes, I have copied it.
You copied it. Okay, you copied it from that file only.
So here it is. I have shared.
Okay. Yes. So that will be easier for participants to find it.
Yes.
Just from where you have you copied? Just show it to them.
Okay.
So I hope all of you have opened this IPython notebook, which is there in the shared file. And all of the code that we're going to run is there in this file. Okay, and we are simply going to copy and paste code from here. So we have already shared with you the code, so that just in case you're having issues in typing the code and something goes wrong, so it doesn't take a lot of time. Okay. Can you just show Vikas from where is this content, this Google Drive code is from?
It's this one. See.
Okay. I can just close that, open it again. So if you just double click on the file that has been shared, it opens in Google Collaboratory automatically.
So when we go down after this meeting, when we go in the reading and writing file section, there I have written a code to connect to the Google Drive. We just have to copy this code, and we here we have to just paste it, like, and then we have to run it using this this menu. Then again we will get a pop-up like we have to connect to Google Drive. We have to click on it, and again we have to choose which mail we want to connect. Here I have one mail ID, and again we have to give access to the Google account. We have to allow it. Now it is mounted to folder content / drive. So from here, this menu bar, we can see that our drive is being mounted and all the files in the drive is being visible to us.
Okay. So what it means is that now we have this folder mounted, which is known to the Google Colab environment. So whatever file we'll drag and drop here will be accessible to the code.
Nilima, I didn't get your question. Can you please rewrite it?
Can you please go over it again? Folder command. Okay, we'll come to it later. I think because we can just start from the remaining Python, and then when the file section comes, then we will go over the folder command because they are not able to locate where it is.
Maybe we can copy and paste it in the chat box only.
Okay, that's a good idea because just copy and paste in the chat box as well. Okay. I will do it. But chat box may not prevent the formatting.
Sir, when I am trying to execute the command drive.mount
Hmm.
G drive, it is complaining about the directory not existing. So am I missing any step here of creating a drive or something?
First, you have to connect. Have you connected? On the right click, top, you have to connect.
Can I go further?
Just wait. Okay, for one last time, we are going from the starting, how to do it. Okay, try to keep pace, otherwise it won't be possible for us to go from starting every time. Okay, we'll come to the Google Content Drive thing later. Don't worry, we'll come to it later. Okay, just for now, I hope all of you have opened a Python notebook, named it, some name you have given name, and you're able to run this print hello world command. Because can you just copy and paste print hello world?
I am at this state like where he explained mounted at content / the G drive.
Okay, we'll come to it later. Just ignore that. Okay, just delete it. Just type print hello world. Okay.
Just we have to type function print, and in function we have to type hello world inside the code.
And that is taken from the first line of the code file that has been shared. Can you just open the Vikas, can you open the file that was shared? Yes.
Here it is.
I hope you're able to, all of you are able to go to this file and copy code from here. We'll come to the drive folder part later. Don't worry, we'll come to it later. Okay, first let us go through the Python basics and then come to it.
And
Okay,
to
good.
run it, to execute it, we only have to press on this play button, right?
Yes. There's also a shortcut control enter if I am correct.
Yes, sir. Yes.
Okay. Yeah. So how do you copy the file? It has already been shared to the Google folder link. Okay, I'm typing that link again for the 4th time. Go to that link, download. There is a file. Within that file, there is a file FDP, whatever is it, NLP FDP _day_1.ipython notebook. Upload that file into your Google Drive folder, which is your workspace, where you would be doing all your experiments related to this lab. And then within that same folder, you create another file, as Vikas already demonstrated, where you will copy and paste code from one file into another file and run code there. Okay, good. So with that, Vikas, let's move forward.
So here we are with the help of print function, we are printing hello world. Then there is also other method where we can use user input to print something. So this plus code will allow us to create another cell. If we click on it, it will create another cell.
Have you run print hello world, Vikas?
No, sir.
Okay, so when we run print hello world, we can see there's a little tab below print hello world which displays the output of the statement, and we can see a green tick next left on the line, and there's also a numbering which has been done, okay, which is 2. So it shows that this is the second line that has been run. When we have a tick and we have a number, it means that line, that block of code has been successfully executed. And while it is executing, we can see there's a round thing going on with a stop button, which means it is expecting. So this is, yes, Vikas.
So with the help of input, we can take input from the user. User-defined input can be taken here, and with default input is string, and it will be assigned to the variable a. So that we are running here using this command. So we have to input something. Like we are input 56, and it will be assigned to variable a. Again, we are printing a. Like we can to print A, we can use this. Only we have to type this, and it will print A. And the data type of A is string, so that we can show you type of A, and it's a string. So we are inputting 56, which is a number, and we are required 56 as a number. So for that we have to typecast it this string into a number. For that we can use in function, like we are taking variable B and we are typecasting this variable A. And again we are with the help of print function we are printing A. Sorry. We are printing B. So here it is printing 56 as a numerical value. Next we have functions like print info. With the help of defined keyword, it initialize. Then we have to write our function name, and again these two are the argument we are passing to the function. And again inside the function we are defining to print a statement. For that for print a statement we are taking two input. For print one we are taking input name, and another for print we are taking input age. Here we haven't defined the data type, and it will use automatically which type of input we are giving to a function as an argument. For that we just copy that code from that. Here we have defined function as I told you, and this we have defined function, then we have to call this function.
Vikas, I have one question here. Here you have written b equal to int of a. Typecasting you are doing, but when I'm doing, I'm getting error of invalid syntax. Same command I'm typing.
You just copy and paste the code, Vikas. B is equal to int a and print B.
Yeah, I'm writing this way only. I have written in chat also. B equal to
A is in bracket.
Okay, I got it. Okay, thank you. I got it.
You have to go through each character, like we are inputting int in a small, then we are using round bracket.
Yeah, ma'am. We have seen what your query, right? So you have put int. So int is a keyword.
She has understood. Her query is resolved. She has understood.
It's resolved.
Just
Thank
proceed.
you.
Okay, so this we have defined function print info, then and again we have to call it, right? For that we have so we are calling print function, and we are passing two argument age and name, and in in age we are passing value as 50, and for the name we are passing value as a word dada. And here it return name and again the value of here we have passed dada and the age 50. Again, next we have class defined in Python.
Can you explain a bit like a difference between print info and print, like
what?
I think print info and
the difference between print and print info.
Yeah.
Print info is user defined function. Print is a built-in function. And in print info, we are passing two argument, user-defined argument.
So here it is also being demonstrated how to define a user-defined function. So which is starts with a keyword def, and then name of the function, and then the arguments that the function will be taking. In this case, there are two arguments, name and age. So unlike C and C++ or Java, we don't specify the type of the arguments.
Yeah.
So we just give name and it automatically it is printed. So the purpose of this exercise is not to make us experts in Python. I myself am not an expert in Python, but just to get a know-how so that we all are familiar with some programming language like C, we can just map the corresponding constructs of a known programming language to Python, and then we can understand what is, the existing code when we try to run code in Python.
So whatever we are mentioning in under print info is a variable, right? Yeah.
The arguments are variables. So name.
So capital N is a variable.
Capital N is it is printing. So that is a string. Okay. So print the first two things, the name colon, that is a string, that is string literal, that is being printed as it is. Suppose in C, if I want to print
hello world, like hello world.
Yeah, hello world. So that is something like that. Then the comma name, which is in Y, so that is the name of the variable, which is it is receiving as an argument.
Okay. So
Okay.
okay. Yeah, right.
And another thing in Python is that we don't have braces to denote code blocks. It's everything. The code blocks are recognized through indentation. So you can see in def print info, colon indicates the start of the functional block. And then after that, you can see the next two print statements and the return statements are indented by a particular amount, fixed amount. All the next three sentences are indented by the same amount. So this indicates the Python compiler that all the statements following this function definition print info are part of the same code block, which is the definition of the function print info. Okay, this is something that we will come across all the time in Python.
Okay.
Yes, Vikas.
Thank you.
So next we are defining class in Python. Like here we have a class name employee. First we have to use class literal, then we are using class name as implied. Here we have passes one in count equal to 0 as initializer. And again we are creating constructor of this class using underscore init function, in which we are passing self comma name comma salary as an argument, where self is restricted to use the value which are passed to it. And then again we are defining
self is like this pointer in C++ or Java. We have this pointer, so it is like this pointer, and name and and salary are variables that have to be passed to initialize this class.
And again we are creating two functions, display count and display employee, in which we have two print statement, total employee and employee dot employee count. Here we are using function f, in which we use this how we want to print something. For that we have to use function before this code, single code. Here we are initializing employee, creating its object employee1, and we are passing the required parameters. Like here we are passing Jara, because its required name is assigned as string, and again salary is assigned as integer. So here we have created two object, and we have passes variables parameters to each object. Then we are calling, with the help of this object, we are calling these functions display count and display employee, display count here and display employee here. So it will print Jara, 2000 and money, 300 when we run it. For that we will use control enter.
So here, employee count is instance variable, class property.
Right. It's a class instance variable. Yes.
And name and salary, sir?
So they also become class variable, but they are passed through here. So they also when we do self.name and self.salary, it is automatically creates a class instance variable. Just that in addition, employee.count is being initialized to 0.
Okay.
Python is very intuitive. It does not have a fixed structure.
Hmm.
A lot of
Okay.
things, if you feel it should work, it works. Like, just like we have, when it says self.name, so it creates a variable name.
Okay.
Okay. It doesn't ask you to first declare the type of the variable or, okay, it
Okay.
is there.
Okay. Understood. Thank you.
Sir, what is self here?
Self is like this pointer in Java and C++. This refers to the class instance. So when we say self.name is equal to name, it means so there are two variables here. One is self.name, that is a variable called name which belongs to the instance of this class. And then
it returns the current variable.
Yeah, and then there is a parameter name which is being received through constructor.
Can you please tell the method signature of display count?
Yeah, display count is given def. Defined def is for defined function. Display count. All functions will receive a variable self, which is this, and it prints. So this function has only one line of code, which is print. Total employee is equal to employee dot count.
And what does it mean by passing f over there inside the print function?
I think if I remember correctly, f is for
formatting, sir.
Formatting. Okay.
Yes.
Okay.
Printf, we have printf function in Java, so we can format our output.
Yeah. Alternatively, if we simply use the display employee, the way it is printing in display employee, that way you can also print total employee, quotes close, and then comma, then employee dot emp count. So this is another. So Python has two ways of printing it. I'm not able to recall the first one is the most recent one. The second one for the display employee is the traditional C style printing thing we have.
Yes.
And what is the significance of passing self as the parameter inside this function?
I think it just gives a way to refer to the class variables.
Constructors, what we are passing there.
Okay. So directly.
Yeah.
But here we are using employee instead of self. We are not. We are using the instance of employee for calling the emp
That
count.
is a static variable. That is a static variable for employee count. Emp count is a static variable, so that's why.
That means we are taking self as a constructor in display employee, but as an argument, right?
Yes. So self is an argument. So name and salary are class instance variable, and employee count is static variable. I'm sorry. Initially, I also mentioned employee count as class variable. Yeah.
Actually, the purpose of self is not to refer to the current object, right? So here we are creating a class called employee, right? So whenever we are creating an object for employees, right? So suppose we are calling upon emp1, right? Is equal to employee and passing as an argument like Jara and 2000, right? So whenever we are creating an instance of that class, that is employee, so that current instance is basically referred by the self, right? And wherever we're inside the init function where we are calling it self.name, right? So what we are doing is that whatever argument that we have received, right, that is name and salary. So we are trying to bind that name and salary with the current object variable, that is self.name and self.salary.
So
my question is,
why the word self, right? Why the word self? Generally, in other programming languages, we don't find the word self, and if we simply refer to a variable, it means it is the class instance variable.
Excuse me, sir.
Yes.
Just to
My
initialize
question is, then why to pass self over there? Because we are not using self inside the function.
We are using self.name.
No, sir. In the first function, display count, there is no significance of self passing over there.
There it is not used, but sometimes it may be used. It is a compulsory parameter for defining
Because
any function.
it is having some confusion because using self without any use.
Okay, it's a default parameter that is required, right? Otherwise, it will start throwing some error.
Is it the way that constructor is defined in C++? This is how we are doing in Python.
Yes, similar to that. So we're trying to map how we do it. So in C++, we don't pass this variable, but sometimes I think in Java, if we want to refer to the class variable where the parameter name clashes with the class variable name, then we specifically use this pointer, right? So something like this, has been made compulsory in Python.
See that when we have deleted a self variable from display count function, right? See, it is throwing error because by default it requires a one positional argument, right? That is self.
Okay.
So it's a compulsory thing which Python requires. Why has it decided to go that way? Yes, I don't know, and I don't find it right now necessary for us to get into, details of why exactly Python does what it does, because the goal is not to become Python experts, but just to know it reasonably in a reasonable manner so that we can use it for programming, machine learning and NLP.
I can say that some of you are like asking that what is the purpose of this init function, right? So it's like it's a default constructor, right? That is run itself, right? Whenever we are creating an object for employee, right? And it is a place where we need to define the local variables, right? That we are local variable or functions that we are trying to bind with the current class actually.
I have a question actually. Is the employee count variable? It is public or private? I mean, are there any access modifiers in Python also?
I think I don't remember about it, so I cannot
No,
comment.
there is just no such access specifiers actually, right?
So if suppose we are having multiple classes inside a class, then how can we declare multiple constructor?
So multiple, no, a constructor would be one only, right? Any class will have one constructor. So why do you want to declare multiple? If you have multiple classes, each class will have its own constructor.
Okay.
So here, for example, if you see the indentation immediately after the start of class employee, you see employee count is after like 3 or 4 spaces from the left. So that means that employee count and all the following lines, that is all the following definitions, are part of this definition of this class. And the line when we say emp1 is equal to employee, bracket open, first parameter Zara, second parameter 2000, bracket close. So that means we are going back to our original indentation and the definition of class employee has stopped.
That is agreed, sir. But at the time of inheritance or polymorphism, how will it decide that which parameter has been called? Based on the constructor only, it will decide.
Yes, so if you're talking about inheritance, it has been a while since I looked how inheritance worked in class. So maybe in that case, so in inheritance, any case, when we say extend this class, so in Python also there is notion of extension. So it will extend, so the superclass will only define its own. The class that is extending the base class will define its own constructor, and the constructor corresponding to base class will be defined in base class. So still there won't be need to define multiple constructors. For example, if class A extends class B, so first we'll define class B, we'll define constructor of class B as part of definition of class B. And when we'll define class A, saying extends class B, there we will define the constructor for class A. Does that answer your question, or if I got it correctly or not?
No, actually, what I wanted to ask is, since method signature is same, underscore init. So at the time of inheriting, how the compiler will be able to distinguish which function exactly we are calling, which constructor.
Okay, you're saying if both classes have the same function signature, then how dynamic polymorphism is implemented. We'll have to look it up. That's all I can say. I haven't used dynamic polymorphism inheritance in Python, but there must be some way of doing it. But it doesn't affect our lab session or the lab session we're going to do now. Because as I said, we are not going to exploit Python as an object-oriented programming language as of now. Its purpose is how to use it to, for machine learning.
Okay, thank you.
Thank you.
So next we will discuss about the data types. So we have assembled 5 types of data types. Here we have number, string, list, tuple, and the dictionary, in which a number data type stores numerical values which are immutables. Here So here we have initialized two variable a and b with the value numerical value 10 and 4. So first of all, with the help of print function, data type of a, it will be print as, let me run first. So it will be print as class type is int. So data type of a is int. Again, we can do various arithmetic operation like addition, subtraction, multiplication, division, exponential, and there is many more mathematical operation which can be performed in the Python. And the first we are using like this, we have to just put plus sign in between two variables for the addition. Here we are assigning the plus of a and b to variable c. So, and again here we are with the help of print statement we are printing it. So we will see here the addition of 10 and 4 is 14, right? Then again we are using subtraction, like we are subtracting value of a minus b. For value of a here we have 10, and for value of b we have 4. And the print statement we have subtraction of 10 and 4 we are getting 6. So similar fashion we have multiplication, division, and exponential. For division, we just have to put slash in between a and b. So here we are dividing a by b. For the exponential, we have to apply two multiplication operator in between a and b. So here a to the power b. So it will be written 10 to the power 4 as 10, 10,000. Again, here we have a second data type, float data type. So for division, here we are dividing to numerical value, but it is not exactly divisible, and it will return float value. Like here it have returned 2.5. So we are just checking with the help of data type. We are just checking if so it return the class type of that value as float. Yes, sir. Again, we can also define complex data type in Python with the help of like we are initializing in which we are using 1 plus 5j. It's in the complex fashion, and again we are using 1, and all the operations which we applied in the complex complex number in our day-to-day life.
Vikas Dubey, can you please mute your mic? If you don't have a question. Vikas Dubey, can you please mute your mic? Okay, continue, Vikas. Seems he's not.
So here we are just showing you the addition operation of the complex number. Like we are adding num1 and num2, and we are just giving two variables c underscore add. So it's print as 2 plus 2, like here it's 3, and 5j plus 3j is 8j. So here we are showing only.
Excuse me, sir, noise are very disturbing.
Vikas, can you see if you have a presenter privilege? Can you mute Vikas Dubey? Yes, muted. Vikas Dubey has muted himself. You can continue, Vikas.
Because I have one question here. Why we are getting data type for A as class int? Means since this is integer type data, but in output we are getting class and then int.
So in Python, everything is a class. So, there's no primitive types as we are used to in Java, that there's a small int and then the big int is a class. So here, that's why it is displaying like that.
Okay, thank you.
Hello.
Yes. Somebody else has a question?
Yeah, sir. In division operator, have to execute a division operator. It shows a float value. Yes, sir.
Yes, it shows a float value. Yes.
So suppose I have an integer value by using division operator. What will we do?
So by default, I think it converts it to float. If you want to let it to be in an integer, then you'll have to cast it to int, and the result also into int.
Sir, is there another solution? Is there also? I think we use another slash. I think double division.
Okay. Okay. Double digit is, I think double slash is for.
Yes, sir. We use in double slash.
Okay.
It shows an
So
integer.
you're telling us that to do integer operation, we should use double slash.
Yes, sir.
Okay. Thank you for enlightening us. Can we move forward then? Vikas, please move forward. Vikas, you're not audible.
Okay, so now, sir, I'm audible?
Yes.
Yes, sir. So here we have two variable, word and sentences. And word having a value, words in single quote, and sentence have value. This is a sentence in the double quote. Which and again we can also quote it in triple quotes. So I'm just copying this code, creating another cell, just pasting it here. And so here I have shown you, like with the help of print statement, I am printing variable word and the value of the word is words. And here it is being printed. And again here with the help of plus, I'm concatenating hello world.
So an important point here is that Python is very intuitive. Instead of trying to go with all the different rules that Python follows and trying to get a mastery of Python based on that, much better way, especially for us who just want to use Python for NLP and machine learning, is to understand if there is a plus thing, what will it do? In C++ or C, perhaps it will throw an error. But intuitively, if you ask yourself, if I'm trying to do plus of two strings, what should be the result? The answer will be concatenation. And that's what Python does.
By default, it considers it as a string.
Yes.
Inputs
If we
to
pass
its
it to
operators.
integers, it will add. If we pass to float, it will add.
Yes.
If we pass to string, it's concatenate. So that's what I mean, that it's very intuitive. Instead of trying to come up with all the possible ways in which plus operator operates, if we go this way, it would be easier for us to understand Python. Yes, Vikas, please proceed.
I have a question, because if we add two different data types, then will it result in, how will it prioritize?
I don't know. Okay, we'll have to try. Most probably, if one is string, another is float, it will concatenate. Okay.
If the data type,
yeah. If one is float, one is string, you can just type 0.5 Vikas and see.
Yes.
Yeah. Print hello and plus 0.5. I think it will concatenate.
I think it shows in a float value. Execute.
See, it will give error. Like we have two different data types. It can't concatenate string and float. Right. Yes.
It was giving error.
It can concatenate integer and float, right? I'm not.
Yeah, in that case, it will add. It will typecast and add.
6.
See, again, what I would like to emphasize here is the goal is not to get into these finer details of Python, nitty-gritties of Python, what will happen if we try to do this, but just to get an idea so that we can move on what Python code looks like and how to make sense of it and how can we modify it. Okay. So these are very nice interview questions or Python mastery questions. What if I try to concatenate this with that and so on? But the idea is that there will be some answer, there will be some result. Either it will work intuitively or it will throw some error. And it is not a big deal if we don't know it right now. Even if we try these things, we'll be able to know it. Otherwise, we'll just spend a lot of time in just going through basics of Python, and we won't be able to move it to NLP part. You're free to ask. Yes, please proceed, Vikas.
Okay, next we have another data type list which contains items separated by commas, and enclosed within a square bracket. Here I have created my list as a variable, and I have passed 6 values inside it. Like I have passed number and string also. So here in C programming we have array. The same similar here it is, but the value inside array here it can be anything, like it can be string, it can be integer, it can be float in a single list. So here I am printing my list and its data type. So first of all, I will run this cell. So my list. So here we can see that my list is this, as I have initialized, and the data type of is list. Data type of my list is list. Again, I am creating another list, which is list of list. Here we one list is 540 and another list we have 741, which is a list inside a list. So first of all, we are with the help of this function new list, we are passing 0. A new list we are referencing to this list, and here we are passing 0, means we are accessing its first element. So here when we see it the first element in the new list is 3. So here we have passed initialize a new list this, and the first element here we have 3. Again, when we want to access the last element, so the new list we have with the help of this we are just mapping this new list to here, and we are again just accessing the last list with the help of -1 as a parameter in the square bracket. So it will return the last element of the list. Here each value separated with comma is represented as an element. So it will return as 741. So as you can see, it return as 741 as an one element. Next, we are using slice operator. In which,
similarly, if we use -2, it will be second last element, and -3. So it's like intuitive. And somebody asked what is single quote, double quote, and triple quote. So all three are ways of representing a string. Okay, but what it's the only thing is single quote should end with single quote, double quote should end with double quote, and triple quote should end with triple quote. Triple quote has a special property of going multi-line strings, of writing multi-line strings. So you'll see a lot of comments as triple quotes.
Multi-line comment.
Yes. So if you want a multi-line comment to be printed, you can use triple quote start. Yeah, line 1, line 2, line 3, and then triple quote end. So it takes multi-line strings as well. That's the difference. Yes, somebody has a question.
Yes, sir. I want
to access the elements of internal list.
Yes. So in this case, if you see new list 1, the 0th element is this 3. The first element is 540, another list. Okay. So now if you want to access the first element or 0th element of the list 540, so we should do my list double indexing. It should treat a 2-dimensional array the way we do it in C or C++. So new list index 1, index 0. So it means new list 1 index 0 1 means go to the first element of this variable new list 1, which is 540, and then again index 0, which means go to the 0th element of this list. Okay, so that's how we access. Yes.
Sir, can you repeat this line?
Okay, Vikas, can you just print value 5, new list 1, index 1 and 0?
Yes, yes. This is in for index 1. Okay. So you are okay.
Just suffix second dimension to it.
Okay.
Yes, one more dimension, index 0.
Yes.
Control.
So it will return 1.
So because still new list 1 is another list, sublist, which is an element of the list, and when we further index into it, we get the 5th element. So it doesn't mean, unlike Java and C++, the entire thing has to be a two-dimensional structure. All elements have to be a list. So it can be combination of anything. Yes.
Yes. Next, we have a slice operator, in which here the reference is like 0:3. So it will give values starting from 0, excluding value at 3. Means it will return value 0, at value 0, at value 1, and at value 2. So here we see like the first 3 element of the new list is 3, 540, hello. The similar here, its first 3 element is this. So it return using this statement. Then again we can also use, like we can also give steps, like we want to skip something at each steps. So for that we have a third parameter, like here I am passing 2, means it will be step by 2.
Sir,
So for
Yes.
sir, in my list, second index value is end with comma separator. Why?
you can remove it
in my list.
It's not required. It's not required. You can remove it.
Okay.
Yeah. I was expecting to put another value there. That's why I have given comma. So here it's starting from 0. It will stop at value 4 and it will have a step of 2. So the value for this, it will return like 3 and hello. So here it will start 3, it print 3 and it will give value and it print hello. Again, we can also reverse the value.
So it uses only square brackets for indexing. If we use round brackets, it will. I'm just answering to the question in the chat box. If we use round brackets, it will take it as a function call, or it will give a syntax error. And this start stop step is like for loop. You know what we have in for loop. For I is equal to start, I less than stop, and I is equal to I plus step. Okay, similar. It just behaves like that. So it means new list 1042 start from the index 0 and at something less than 4, which would be 3. So it will go from 0, 1, 2, 3, and then it says step 2. So it will print 0th element, then 0 plus 2, second element, and then 2 plus 2, 4. So it will go to the 4 index, but 4 index is not less than 4. It will stop.
Yes.
Okay. So 042, as Vikas has written, behaves as start, stop, and step. So it is similar to a for loop. For I is equal to start, I less than stop, and I is equal to I plus step. So that is something we all will be able to relate to. How does that I behave? Okay. Similarly, it is happening here. So we are saying start at the index 0, start at I less than 4. So stop at value 1, value less than 4. And what is the step to be taken? Take steps of 2. So what is the first value it will take for I is equal to 0, I less than 4, I is equal to I plus 2, it will take 0. And then we have an increment operator. So it checks, is I is equal to 0 less than 4? Yes, it is less than 4. Then we do I is equal to I plus 2. So it will go from 0 to 2. Is 2 less than 4? Yes. So it will print the second index also. Then 2 index also. Then it will do I is equal to I plus 2. Now I will become 4. Now 4 is not less than 4. So it will stop. The iteration will stop. Okay, so that's how it works. And -1 means step -1. So what does intuition of -1 means? We are going the reverse order. Yes, Vikas, please proceed.
So here we are reverse indexing with this values, like we are passing 3 parameter in a square bracket. We are just leaving 2 as a bracket, and we are just passing the last, like we are using from the last index of the list. So it will print as a reverse of the whole list. Again, we can compare two lists. With the help, I have initialized two lists as a variable a and b, and I'm just comparing is using a value a equal to b. So it will, if both the lists are equal, it will print true, or either it will be print as a false. Again, with the help of some functions like length, max, or mean, we can just extract the length of the string. We can extract the maximum value from the length from the list, and we can extract the minimum value from the list. For that, for the list, I'm using for the list 1. Here, the length of the list is 4, like 1, 2, and 3, 4. And the maximum value from the list is 4, and the minimum value from the list is 1.
हाँ तो ये बनना है ना वो बना तो दिया उसने अच्छा वो अच्छा हाँ ये तो
So next is tuple. Tuple is a immutable list which it is used read only and doesn't change, and define using the round bracket.
We can just skip tuple. Tuple is same as list, just that list use square brackets, tuple uses round bracket, and tuple values cannot change. List values can change. If we want, we can index into a list and change the value, but if we try to change a tuple value, it will give error. Rest, all the syntax are the same as the list.
Yes, all the syntax and all the functions will act except adding or removing.
What are the use cases of tuple?
So let's say you define list of names or list of constants. You don't want them to be changed, even mistakenly. So as a programmer, you can say, if I want to change, I can just change a type of, the variable as list, which is fine. But just, if you want to prevent mistakes inadvertently, so you define something as a tuple. So again, there is no data type tuple. You don't write this is equal to tuple or something. You just differentiate it by using a round bracket.
Okay, thank you, sir.
And the same,
move on to next.
Yes, sir. Yes, and all the presence of the list.
Yes, does anybody have a question? Okay, no.
So this
Yes.
F thing that you keep using inside print, is there a specific reason for using it? I mean, we could get the same result without using this F thing.
Yes, we can get, so F is a sort of format, is it? Does it work without as well? Vikas, can you just try removing F and see?
With lists, it does, I think. Tuple list.
If you just do any print statement, can you remove letter F from there and then try to print it? No, it doesn't work. No. What if we just delete the letter F and then print it? Will it print?
Will not realize that it's a variable.
Right. So that's why F is used. If you just simply delete the letter F, it will not work, right?
So yes, it will not work as we are passing our functions value. Yes. For mapping, like it's a functions printf functions.
I think it's better if you use this way if you're getting confused with F. So F is the more recent way of printing in the the more modern way of printing in Python. I'm sorry.
One question is, can you list us some cases where it is preferably we should use tuple rather than using list?
So as I said, let's say you define set of constants. Okay, let's say you define column headings in data type, and you don't want them to change while printing the output or something like that, even by mistake. So you pass it as a tuple. It is just a coding convenience. Just like you define a constant keyword in your own while doing in C++ Java, you don't want things to change. Something like that is there.
Sir, one more question is related to Google Colab.
Yeah.
Is that while we are making some deep learning neural network program in Google Colab, and we need a GPU, and sometimes Google Colab says that the GPU is not available. So what should we do in that case?
So see, Google Colab is a free thing, and just as any other free thing, it is not unlimited. Okay. So if your code requires, so it is on a sharing basis, you know, if so maybe if the demand is too high at that point of time for the resource that Google has allotted to certain set of users, then you won't be able to, you know, it will give that error. Alternatively, you can upgrade your Google Pro license, Google Colab license. So the Pro license is, I think, only like $11 a month, which on a department level, or you know, you can ask your institute to purchase like 5-6 licenses on a month, which is not a big deal, which is not a lot. Maybe, you know, you can just take 2 or 3 licenses which as faculty members or as students can share among themselves. So that gives better access, you know, that gives more access to resources like GPU and RAM and so on. And they have even one more advanced version, which is $50 per month. You know, if you're really doing that kind of application, you can do that.
One more question related to deep learning neural network again, that if I am making some sequential model and I am having only one layer, and suppose the actual and predicted values, then I am taking the root mean square error, and suppose it is 50. So by adding more layers, are there any chances that I may get reduced mean square error?
Generally, yes, because more layers means more abstraction, the deeper learning is going deeper and deeper, right? So that's what, you know, these big companies do. If you see Deep Face, it had 17 layers. More layer also means more parameters, and the more parameters you have, they require more data set, but the better the learning would be. That's why you see Facebook, Google, all these state-of-the-art models come from their laboratories because they have supercomputing powers. It was Microsoft and Google. Okay, so they have like tons of layers, unimaginable number of layers and so on. Yes.
So next, we have another data like dictionary, which is enclosed in a curly braces, and it uses key value pairs. So here I'm initializing a dictionary with a variable in month in which I have a key, like I'm using Jan as a key and the value 31 as a value to the Jan. Similarly, I have given up to July and its values. So here I'm, with the help of print, I'm printing the dictionary. Here I'm passing the month, dictionary name, and here I'm passing the type of the dictionary, data type of the month, which is dictionary. And again, with the help of this curly braces, we can initialize dictionary, and Dix1 is initialized dictionary 1. In Dix1, we are adding at key 1, we are adding this is 1. At key 2, this we are the value is this is 2. And in dictionary 3, at key 3, we are adding this is 3 as a value. So when we are printing dictionary 1 with the help of key, we have to pass key, and when we use this statement, it will return the value which is assigned at key 1. So here it will print this is 1. Here I have shown it, this is 1 is being printed with the help of this statement. Right. Again, we are with the help of dix1 dot value. It returns all the values which is associated to dictionary 1, and dix1 dot keys, it returns all the keys which is associated to dix1. So in singular, all the values of dictionary.
Ashima Yadav, can you please mute your mic if you're listening? Ashima Yadav, can you please mute your mic? Okay, whenever she will get to
yes. So these are the values which I have assigned to each keys, and these are the keys of the dictionary 1. So next we have to make decisions. So to make decision, we use here we have given you 3 statement: if statement, if else statement, and elif statement. In if, here I have given one variable with the value 100, and if variable 1 is true, Means if condition is satisfied, it will go inside this this loop, and it will print 1 and got expression value 1. Here 100 ones, the computer will assign it as a true, means we are getting something value instead of value 0. So it will print this statement, and it will print variable 1 as 100. So let's see what we are getting. So here we see that print 1 statement is being is used, and the statement is inside the print is being printed, and another is variable 1 is being also printed. So for second variable, we are assigning it as 0, and variable 0 here if it's false, means we are not getting inside this loop, means, so that's why this statement is not being printed, and this variable also is not being printed, and it will execute the print statement outside this indentation, like it prints goodbye.
Excuse me, sir. Sir?
Yes.
Can you repeat it once?
So first we are assigning variable 1 as 100. Then we are checking whether there is a value or not. Like value 0, here computer understand it as false, and greater than value 0, computer understand it as true, right? So if something is true, it will get inside that loop or indentation, and it will print this, it will execute the statement inside that. So here we have given two statement, print a statement, and it will execute both the statement. That's why we are getting these two outputs. And again, from with the help of this code, we are getting only this, because here condition is false. So that's why this two statement is not executed. Only the statement outside this if condition is being printed. That's why here goodbye is printed. Okay.
Whether by default it is taking 0 as false and positive value as true.
Yes, its computer understands 0 as false.
To see no 0 value is taken as false.
Next, we have.
This is what is recommended to you also, that right, what Vikas is doing is copying code block by block and pasting in a fresh file and then running it. So if you get time, I know it's already 8:15, but before we come back for tomorrow, try and do this for the two code files that have been shared with you, and try to get a hang of how Python works. Yes, Vikas, continue.
So next, here we are executing if-else statement. If I have assigned one, first of all, I have given one variable num1 2, which is, and the value of num1 and 2 is assigned as 11. And I have given one condition, like if num1 2 is less than 30, means if this is being true, it will print this statement. Otherwise, it will print this statement. So here num1 2 value is 11, and 11 is less than 32, means this condition is being true. That's why here this statement is being printed like 11 is less than 30. If I'm assigning here it as 16, it will print the second statement like 16 is greater than 30. Else statement is being printed because this condition is being false. That's why it goes to the another statement, else statement. Next, we have if-else conditions. Like I have given variable name num1 2 as 15, and I have given three conditions like num1 2 is less than 13. It will print the this statement, and if num1 2 is less than 20, it will print this statement. Else, it will print this statement. So first of all, I have assigned num1 2 as 15. So for this condition, it will print the second statement because it is greater than 13. So this condition will be false, and it will fall into, then it will go to if condition, and it will check here whether this condition is true or false. If this is also false, it will come to else. So see what happened. So here 15 is here 15 is greater than 13. So this condition is false. So it will come here elif, and 15 is less than 20. So it will print this this statement. Again, if we check for like greater than 20, like we applied here 34. So it will print that 34 is greater than 20. So see, 34 is greater than 20. Means both this condition is false, then it comes to else condition. Next, we are going to loop construction. In loop construction, we are using while loop. For using else with while loop and range function, we are using two functions, range and enumerate functions. So first of all, while loop, it iterate our block of code as long as a text expression is true. So this is while loop. This is condition for the while loop. So here we are just initializing variable count as a 0. If count is less than 0, until it will execute this statement. If count is equal to 5 or it is greater than 5, it will print this statement. So we can see that this while loop is being called until this expression is satisfied, right? So this count is value here. Count is being passed, like first it is initialized at 0. Again here it is being added, +1 is added, incremented by +1, and until it is being false, this statement is being executed. Next we have a for loops. So this iterate our sequence or list, tuple or dictionary or string. So here first we are just creating this range function, gives value like from 0 to 4, list of value like 0 to 4. So let me show you. So we can see like if we are passing range, in inside range we are passing value 5, it will print like, it will print 5 from 0 to 4, it will print 5 sequence, but it is less than 5, like. So here the range, the count value will be from 0 to 4, and we can see that it will print like this is a count from 0 up to this is a count to 4. So here you can visualize it. Next we have else with while loop. So here again I am initializing count as 0, and this condition is being satisfied till this. If this condition is satisfied, till this statement will be executed. Otherwise, it will come to else statement, similar as if else condition. So here we can see like until this condition is satisfied, it print from 0 is less than 5 to 4 is less than 5, and again here again this condition get false. So 5 is not less than 5. This condition, this statement is printed using else condition. Here I have shown you range. Let me see you again. In the range, this statement will print a value of range, like it will start from A and it will print up to B minus of 1. So here I'm passing value A as 3 and B as 10. So it will print the value starting from 3 and it will end at 9. And again, here we can assign gap, like I have shown you in the slides of the list. The similar fashion, it will be print like the second step is time. It will start with the value 3 and the second element will be 4, skipping the first element. So this list will be printed with this statement. Again, we can also print the starting from range, like I have seen given you value A and 3, and the same is being printed here. Then we have another function like enumerate. When we are required value with an iterator, like we want the value as well as the indexes, then we use the enumerate function. So here I'm creating a list, my list, in which I have given 5 words, and we are just printing this my list using the function enumerate. So it will print the value with the index. Here the index of this is 0, as list started indexing starting from 0 and it ends up to n minus of 1, where n is the length of the list. So this having index as 0, y having index as 1, and is having index as 2. So and here again we can also start the indexing, like I can start the indexing this from 5 with the help of we can pass a value enumerate function as a second parameter. So it will return like it I'm starting with the help of after 5. So this is assigned index with the 5 and y is assigned index with 6. Next we have to read and write files from the Google Colab. For that we have to mount drive to this collaboratory file. For that we have to use this code.
Hello.
ലെഫ്റ്റ് ഫിംഗർ അല്ലേ മൗസ് പോയിന്റർ ഇങ്ങ വരണം മൗസ് പോയിന്റർ ഇങ്ങ
Please mute to mute Abhi and Ashima.
Please mute Abhi and Ashima. Please mute your mic.
Can you please mute everyone, sir? These people are creating disturbance.
I was commented and said that muscles are looking great. मैंने बोला तो सही comment कि muscles are looking great, muscles are on fire.
So this is the code by which we can connect to the Google Drive.
जब देखो तो problem ना
connected.
Complain नहीं करता रही हो. Yes. एक सेकंड होल्ड करियो. हाँ वो
What is this mount, sir? Which is this mount?
मैं बंद अरे मैं कर ही नहीं अरे नहीं हेलो या भाई बाय द वे मैं बता दूं मेरी शादी की मैंने बताया ना इंटरव्यू शिफ्ट हो गया.
So
Sir, please mute these participants.
I think everybody should mute their mic.
Yes.
देखते हैं सर, देख हमको भी पूरा आता नहीं है सर, ट्राई करते हैं.
Sir, I have a doubt.
तो तेरे लिए क्या important है?
Hello.
So here
JP sir is doing the setting. Please wait.
Can I continue, sir?
Just wait. Hold on for a minute.
Okay, sir.
नहीं 19 को 19 को पापसी का बर्थडे होता है.
Sir, this is permanently stored in the drive, like when we mount it. Is this permanently stored? Sometimes
Yes.
like after
See, any computer program, if you want to access files, so the files has to be stored somewhere, either on local drive or remote drive, and the program has to be given a way to access that folder, right? This is something which we do with any program. So this command, actually drive.mount, allows the Google Drive to act as a local folder. Google Drive folder to act as a local folder. So what it means is you can upload the content in Google Drive. It will map your Google Drive as a local folder to this program, and this program now can simply access the files in the Google folder. Yes, Vikas, can you show how we select the path from content G drive, my drive? What is the root of content G drive? Vikas?
Yes, sir. Yes.
Just show I think the G drive is a G drive folder is there.
Yes, sir. We are just mounting the content from the G drive.
Yeah. And show where this sample.txt is created.
Yes, sir.
By navigating in the folder drive. See.
Yes. When we click on drop down arrow, and in which folder you people have data uploaded the file. Like I have uploaded in NLP _day1 lab session, right? So I'm just clicking on the triple dot, like this is the folder I'm clicking on, triple dot, single click, then I'm just copying the path, right? See, see. So this is the path, I have copied it. Right. So this is a path where this sample.txt is available. So here I'm just concatenating the path using plus, and this is this all things will return like this path plus file name. Like here it will be like this. This just ringing.
I think Smita, maybe you're still getting error because either you did not connect and you did not mount the drive. So maybe that's why you're getting error.
Yes.
The first thing you have to allocate.
This will be the whole path which will be passed to this here, and I'm opening this file as in a read mode. Here we applied read write mode, right? So it will open that file sample.txt, and it will read by line and line, and it will print it. So we are opening it using a file. Then we have to close it using this close functions. So these are the two statements which is inside that txt file, which is being printed here. Next, we want to write. So if we want to write something, and with the help of this this function, we are just opening write underscore sample.txt. It will create write underscore sample.txt where the path we have assigned it, and it will open it in the write mode, right? It will create a file if there is not available, and if it's available, it will just replace the content of that file. So we are just writing this to a statement. This sentence is written sentence /n and by using the write function, and we are just closing it. There is other options also. With the help of this with operator, we can also write sentences inside the file. So when we run this, it will create a file here. The path where we have given it, it will create like here. I have given write sample underscore sample dot txt. When we open it, it will see. This is not write sample here. It is. So this is the second sentence written in file by using the write function. It's not getting up.
Open, this is second sentence is not written, sir.
So we can also use read and write simultaneously. For that, I have given this code.
Vikas, can you just browse and show how did you open the file on the right?
Okay, okay, sir. Okay, sir. So we are just clicking on this.
We navigate in the folder view on the left, and then we select the file
We
under
navigate to the folder where we have the path we have given to it. Like we have given a path content underscore G drive, my drive, and NLP underscore day1 lab session folder. So we have to navigate this path, and there we have to find write underscore sample dot txt.
Vikas?
So here, yes, sir.
Vikas, can you please click on the NLP FDP Day-1 folder? This one. In the NLP Day-1 lab session, the first one file.
So I think so you people have got all the files.
No, I have got the file, but the problem is that it opens in the right side, and when I try to copy, it gives some absurd kind of things.
Can you just open and see what does it show?
Yeah, Vikas, you please.
Just wait, sir.
Excuse me, sir. How to get that NLP Day-1 session?
No, not from here.
From your browser.
This is NLP Day-1 lab session. The files
from your folder view in the collab.
Yeah, from your folder view in collab.
In line number 36, what exactly you are doing?
You will explain. Just hold on. Can you open the collab view, Vikas, where you had opened the file? Yes. Click on here.
So see,
the first file. No, not that, the collab FDP folder, the first file in the FDP folder.
the link which you have provided, sir?
No. In your left, where is this, the file that you have opened, where is this located? Can you navigate to that point, to that folder?
So we are going like we are clicking on.
Just go to the folder. Just go to the folder. Directly go to the folder.
Okay, sir.
Yes, in the folder NLP Day-1. Can you open the first file NLP underscore FDP underscore day underscore 1 underscore 1 dot IPNB? Just double click on it. How does it open?
So from here we can't open it. We have to just navigate to this drive, sir. Here we have to double click it to open that IPNYB file.
Okay. Thank you.
Please proceed with this.
So here we are using simultaneously we are using read and write operations. We are doing read and write operation. For that we are just opening sample.txt using this path and sample.txt.
Excuse me, what exactly you are doing in line number 36 here?
This one, sir?
Yeah.
So first of all, we are just creating a write underscore sample.txt file, sir. If it is not available there, it will create this file and it will open in write mode.
So
Then
in the
we are writing this and then we are writing this sentence inside it.
inside that file
Yes,
write sample dot txt.
We are just writing using h dot write with the help of this.
Okay.
Yeah.
Sir, small doubt, sir. With open, sir, it is not updating in file. With open. No, sir, second way.
So it's being updated, sir.
When you open, sir, it is not updated, sir. Just to show me, sir.
Okay, wait, sir. See, this is a file. I am deleting it, removing it from here. Right, it's fine. Then we are just running this code. So what will happen here? You have to just refresh your drive. See, write underscore sample.txt is being created, and when we open it, here, see, this is the second statement written in file by using write function. This is the line I have to write inside this write underscore sample.txt file. Okay. So this is the statement which overwrite the first statement. Okay. So here again we are using read and write in simultaneously. First of all, just we are reading the sample.txt and we are just copying the all the statement, all the value inside sample.txt and we are just writing it to sample underscore copy.txt file. So here for your visualization, we are just opening write underscore sample.txt file and we are printing the value inside it. So we are printing it in a list manner. So this is the statement. This is the list. Yes.
The path is a keyword or any file path name?
Path. It's a variable, and we are just giving the path. Like
it can be any variable. It can be ABCD also.
Okay. Why you use plus sign here?
It is for concatenation.
The sign is for the concatenation, and I have shown you the final, the path, how final path will be look like.
So is appending, concatenating the name of the file sample.txt to the folder, the location
So
of
this
the
will be
folder.
the final path. It will be final path. This will be the look like for this sample.txt file. Okay, next we have to we are using we have to read CSV file, like that was for the txt file, and for the CSV file we have to use this code. So we are just importing CSV function, and with the help of that we are just reading CSV file in which we are just opening example.csv in and we are just reading the value, and with the help of csv.reader we are just opening the example.csv file and the delimiter means how the data is being separated. It's being separated by tab or it's being separated by comma. So that's why here delimiter is used, and we are just printing the values using this loop, for loop. So this is the value inside example.csv file. The first value we have, like, it's the date value and the 5, 8 and the rate. There we have 4 columns and the 3 rows. with the help of CSV writer, we can also write values inside any CSV file, as we have write value inside the any text file. So for that, we are just importing this. Again, we are just creating list of datas to write inside sample2.csv file, and we are just opening this file in the write mode, and the new line is you can say space. For that, we are just creating passing the object here, and with the help of CSV writer, we are just writing inside this sample2.csv file. And for that, we are just writing using write row, means we are writing single row at a one time. So this is the value, and simultaneously we are also printing what is being written inside sample2.csv file. Next, we have NumPy, which is a fundamental package for scientific computing with Python.
Because I think we can stop here today and talk to JP sir, because even this thing is also left. I mean, NLP part, basics of NLP processing operations also left. So maybe we'll continue this lab tomorrow. It's already 8:50.
Yes, sir. It's already, so it's really, I'm really thankful to all the participants, those who are there till 8:12 now, right now it is. And it was really nice talking and interacting to all of you and getting your enthusiasm. So that your enthusiasm basically will make us more attached to this workshop, and we will be ready and we will be really giving more, in fact. Looking at the interest of the participants, if all the participants agree, if even some of them, then what we can plan is we can plan some more session on Saturday. Otherwise, Saturday is a holiday. So if you agree, we can take some session where you can take this repeat one.
I think, sir, the NumPy is almost done. Immediately after this, we'll move to pandas and NLP. So I think if
I'm in general saying, sir, for this whole week, if we have some queries, some of our scholars, we can put some scholars, and even I can also be there. We can interact, because since they are eager to learn.
Yes, so we are really encouraged by your response that you're asking questions and trying to participate. So we are really encouraged by that, as JP sir also said. Somebody mentioned about Unicode error. You can try converting your file to Unicode. There are text editors for that, or you can just look up online.
So you can put U. You can start with U, and then instead of like here printf F is shown, you can use U. Or there is some like code is Unicode. There are some features. I cannot remember everything right now, but that can be done even in the inline also, sir.
Sure, sir. So that is all. Thank you, Vikas.
Stop here. Say goodbye to all of you.
Excuse me, sir.
Nice interaction.
Sir, what about the attendance? Sir, attendance.
Attendance will take once in a day. Say here, I am not interested in attendance. If you are interested, since most of you are right now still connected, that proves your attendance.
Sir, please share this code, sir.
Sure. If someone is not interested in learning, just taking attendance, will it serve the purpose? So that one attendance will be sufficient for me.
Okay, the code is already shared. The JP sir has also emailed the code. I have put on the chat box multiple
times. In the Canvas link, I have already uploaded the presentation for the first session. This code and all this data set is already there. Sir has already shared it with the Google link. So you have a number of outlets where you can download.
Yes, and it is strongly recommended, since you are showing so much enthusiasm. Spare an hour or two before you come back tomorrow and run the code, what has been shared with you, and try to get a hang of it. Again, we don't have to be experts in Python. That's not the goal. The idea is just to familiarize ourselves with Python. Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay. Thank you. Bye. Good night.
Thank you, sir.
Thank you so much, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Namaste, sir. Good night.
Thank you.
sir. Thank you so much, sir.
Good night.
धन्यवाद सर.
Thank you, sir.